Thank you, everyone. Thank you who are here in the studio with me. I don't feel alone anymore. The last 2 years have been quite a little bit alone here on the stage, talking to you over the camera. Now I'm here together with the rest of you. Now, CERT LV is very honored to bring back the cyber conference this year, happening on site, with having viewers here on site and having you also remotely joining us wherever you are. CERT LV has been very busy this year. I wouldn't say that all the other years up to this point have not been that busy. The other years posed other challenges, and the theme for this year when we started the conference at the CERT LV, we decided it's going to be energy. We didn't know at the start of the year, in December actually last year, how important the energy is going to be, no matter what kind of energy. Inner being, electrical energy that we're currently hearing everywhere on the news. The energy is around us. And with this, I would like to energize this conference here, especially while feeling you here together with me. So the program and the flow is going to happen as follows. We're going to have 2 days fully packed of talks. It's going to be from 2:00 p.m. local time, UTC +3, up until 6:00 local time. There are going to be 4 talks. Each talk will take about 45 to 50 minutes, including Q&A session. We'll have a 10-minute break between those. You'll have a chance to, although I would not recommend, to switch to the other session. I would encourage that you stay here with me and listen through other tech talks and enjoy them. The questions. We do encourage that you ask questions. There are at least 3 ways how you can ask questions. The first one, if you're here, raise your hand and the microphone will be handed to you and you can ask a question. If you're remote, please do join the Discord channel that is announced on our awesome webpage. Our CERT LV designer has spent a lot of time on implementing these ideas and bringing these marvelous pictures to you. Discord channel is meant where you can also interact with our speakers after their talk is over. You can carry on asking questions, and you can carry on engaging them with further discussions and actually expanding your network and knowledge as well a lot. And also those who are joining us directly from the YouTube stream, please use also the YouTube stream. If you want to ask questions, we will collect them and we will address them here through me as well. All right, with these few messages of the organization, how we are managing this. There's already the cyber battle is ongoing. Here we are running this CTF, the Capture the Flag event, which already started at 9:00 this morning. We've seen already multiple teams fighting for the first top 5 positions, and the battle is very, very fierce, but I will come back with a more in-depth view on the CTF activities at the end of the day. But let's start our, venture into the technical track. And the first speaker I would like to invite here on the stage is Jamie. Jamie, welcome on stage with a round of applause from everyone who's here. Jamie, the crowd is yours.
Welcome, everybody here and everybody that is online as well. This afternoon, I'm going to talk about building highly available, secure infrastructure based on this new buzzword of Zero Trust. Before I dive into that, though, some people will probably think if you're going to be talking about high availability, then you're going to be using the number 2 a lot. Because there is a kind of historical understanding that if you want HA, then just get another one, and if the first one goes wrong, then you've got the other one. Well, I'm going to try and avoid talking about the number 2 as much as I can, because one of the things about Zero Trust is it changes the way the world works. And so the way we implement HA in this new world is also going to be very different. So I'm going to take you on a journey looking a little bit about what Zero Trust is. Then we'll have a look at how it manifests itself, and we will see some of the tricks you can play to create a highly available infrastructure. First of all, I'd like to do a little bit of revision and just review our understanding of what Zero Trust actually means. It is a major trend and topic that is currently flavor of the month in the security industry. Arguably, it is a philosophy and a strategy that is going to change the way a lot of us put our infrastructure together in the coming years. And if we haven't started that journey, then a lot of people certainly are considering that they need to start that journey pretty immediately. Sadly, it is also a marketing buzzword. And there are plenty of organizations around who would produce anything and they will just tag it with Zero Trust to make you believe that it is based on the principles of Zero Trust. So sadly, you need to think about things like the hype cycle and where you might believe we've got to on that cycle at the moment. And yes, I think there were a lot of people who were trying to associate themselves with Zero Trust, possibly wrongly. Possibly that causes this peak of inflated expectations that everyone should be used to from Gartner's hype curve. But I'd like to think that we've got through that early phase now, and that if we're serious about IT security, then we should be serious about Zero Trust. And now we're starting to get enlightened as to what the benefits of Zero Trust can actually bring. So, a lot of people will ask the question, why should I be interested in Zero Trust? And what is it going to do for me? And it comes back to a problem that has existed for a very long time, and that is to do with a certain gap. That gap exists because we've all been using networks for as long as we can remember. And their real benefit is they make it super easy to connect. We come to a conference like this, we can just join the Wi-Fi network. It is very, very convenient. Sadly, in enterprises, we also have this requirement that we really want to restrict access to applications, particularly to critical applications, and that you should really be focusing on individual people and making decisions about whether they should have access to that application or that data or not. This creates the gap. We're using basically the wrong tool for controlling access to our critical infrastructure. The problem with letting the network do our application access control is that TCP/IP itself does not have a very good security model. It has always encouraged this really bad behavior, which is connect first and authenticate later. That means that typically all the resources are visible on any network that you have connected to. And only when you've actually got through to the target, the application or the data, do you then authenticate. And in this modern world, if you think about that, it just seems bizarre that we still operate that model in the current climate. The other problem with TCP/IP is it doesn't really have a policy language. It was never designed with that in mind. So if you ask the question, should a particular IP address have access to another IP address, then there is no way of actually deciding that apart from possibly just with a yes/no answer. So the big problem is that if we pursue this idea of using networks to control access, then we end up with wide open, flat networks. Users frequently having access to hundreds, possibly thousands of resources if you work in a large corporation. And the network security teams basically give up on the idea of actually trying to control who has access to the network and rely on authentication when you actually hit the targets to define who should or should not get access. This is the reason why many networks have been hacked into in the past. And this is the reason why we've seen headlines time and time again once people break into a network and then exploit lateral movement to explore the network and find all sorts of interesting resources. It's that which Zero Trust is trying to address. This is a definition by NIST, which defines what Zero Trust means. It's a set of cybersecurity paradigms that move defenses from static, network-based perimeters to focus on the users, assets, and resources. Now, Zero Trust arguably was a phrase that was first coined by Forrester some years ago. And they pursued that idea fairly relentlessly for several years, and eventually it was picked up and has really become the backbone of the latest thinking in terms of the way we should be building our infrastructure. There are certain tenets that relate to Zero Trust, and you can see these really if you look anywhere, including Forrester, but NIST and others. And that is to ensure that all resources are accessed securely, regardless of the location of either the user or that target resource. That we should use least privilege at all times. And that we try and stay in control of our infrastructure. And we inspect what the infrastructure is doing on an ongoing basis, so that rather than waiting for something to fail or somebody to break in, we can maybe see things happening in real time, predict outcomes, and avoid bad outcomes by taking corrective action early. So what Zero Trust does is it compensates for the weaknesses I spoke about earlier. Zero Trust works backwards in terms of TCP/IP. So you authenticate first, then it will allow selective connectivity to authorized resources. That means that if the bad guys succeed maybe in getting through the authentication layer, they will still only see the original intended target that that user would have enjoyed. They will not be able to see your entire infrastructure. The other thing we need to address is the policy language. I've mentioned that already, that TCP/IP has a very weak policy language. And we really need to change that yes/no answer that we had previously to something more like a sort of it depends answer. And in theory, it should depend on almost anything you want it to depend on. And if the Zero Trust solution that you might be looking at can't answer a lot of these questions, then maybe it's not the right Zero Trust infrastructure for you. But we should be able to decide what our security policy asks us to check, and then simply implement rules that wrap around your security policy. Even down to interfacing with other systems, such as shown in the bottom right here, you could say, why should I let a third-party service engineer come into my network to access a system if there is no ticket open in the service desk system? So we shouldn't have open access. We should have access that is there when it is appropriate and only when it is appropriate. We've all heard stories about organizations being hacked into through things such as aircon systems or heating systems because you've left access to those systems open for engineers to provide ongoing maintenance and support. That is not zero trust. So NIST defined a relatively complex-looking model for what zero trust should look like. It can be a bit scary, but somewhere in the middle here, you actually have the piece that does the work, whether it be control plane or whether it be the data plane down here. But the important thing is also to look at the associated systems that can interface in and out of your zero trust control plane. And these things that sit here on either side are the sort of things which can either feed into your zero trust system to make its decision-making capability richer, or can read in real time from your zero trust system to affect changes based on what it is seeing. Good example down the bottom here is SIEM systems, where you may well be able to set up alerts in here based on what this system is doing, and then those alerts in themselves could modify the behavior of this system. So you don't need to be working over the weekend when somebody is attacking your organization. You could actually use this type of approach so that it can defend itself over the weekend, and you come in on Monday to see what it's been up to. If we simplify that down to look at what the core might look like, you could end up with a policy decision point, a policy enforcement point. Obviously, you've got a user on the left, the subject, and they probably want to connect to a resource on the right-hand side here. And there is an implicit trust zone wrapped around that resource, which probably goes back as far as the policy enforcement point. And it's that implicit trust zone which you need to control access to. Right, now the CSA defined something called a software-defined perimeter, and this was done, I would say, almost in parallel from a time point of view with the concept of zero trust. But this SDP model that the CSA came up with actually represents a very good way of implementing zero trust in an organization. So zero trust isn't something you can go and buy as such. It's more of a concept, whereas the CSA's model for SDP is something, it's more real, if you like. It's something you could go and purchase if you wanted to. It looks pretty similar to the last diagram I just showed you. At the end of the day, you've got a policy decision point and a policy enforcement point. But typically, you'll all be used to this in your own organization. You have people, whether they're working at home or whether they're working in the office. Those people should be known to your organization, possibly through some kind of identity provider service, whether that be in the cloud, such as SAML, or maybe in your own organization. And these guys need access to some protected applications. So I'm going to use this model for the majority of the rest of this talk, so keep this model in mind. And so what I'd like to do is to move on, now we've finished our revision, and talk a little bit more about highly available zero trust. Now, as it says here, by its very nature, if you deploy zero trust properly, then it will be the backbone of your enterprise's connectivity model. It's the glue that holds your entire organization together. Now, you can think of zero trust as being like an application layer. It sits on top of your network layer. So we're not throwing away TCP/IP and its inherent problems. We accept the network as it is. We can probably simplify the network massively compared to how we have it today, because we're no longer trying to make the network do things it wasn't designed to do. So you can think of Zero Trust as being an application overlay that we're sitting on top of our network infrastructure. It provides the control plane, and the network itself can go back to doing what it was designed to do, which is connectivity. Now, because it's the glue and it holds everything together, HA is absolutely critical. And in the ZTP world here, it's much more important to approach it in a holistic way, rather than just saying, I need two of everything. So I'm going to take you on a journey looking at a number of tricks that we play at different points in our Zero Trust journey. And they're shown here on the screen. So we need to understand what single packet authorization is, how that works, how that enhances connectivity for users. We need to look at the policy decision points, the controllers, making sure that they are highly available. Ideally, it should be a token-based system which provides a great degree of tolerance. I've mentioned that it should work for everyone, so context awareness is critical. You don't want to give a third party the same access as your employees. It needs to adapt in real time, because the situation may change. It may change in your enterprise. Even the user situation may change. And you need to guarantee that users can always connect to what they need to connect to. So that's uptime. And finally, I'm going to take a look at monitoring, because if we don't monitor these systems in real time, they might as well not be considered as HA. So let's start by talking a little bit about single packet authorization. Now, this is based on the older idea of port knocking, which came from the Linux world. And the idea with port knocking is that a system would perform some kind of handshake with a target before it was allowed access. And port knocking in the old days just used to randomly knock on a number of different ports in a known order. And if you were a good guy, then you were allowed access. But if you were a bad guy, then access would be denied. Now, these days, we don't need to do this using port knocking. There are alternative approaches that you can take, because we have a lot of very good cryptographic tools around us these days. So it is those tools which we will use for things like SPA today. So the system I'm showing today uses SPA, and it's based on sending a specific signed encrypted blob of data, first of all. Now, the way we've done this is we have built it into both TCP and UDP. So you're allowed extensions in TCP, and so we have allocated an extension to ourselves, and the initial TCP handshake packet has an extension. It's an extra 94 bytes, and that contains this single packet that we send. Now, we use both TCP and UDP-based SPA. They are different, but they have distinct advantages. Now, TCP has the advantage of masking a TLS port. So if you have something like a Heartbleed vulnerability again, then it couldn't be exploited directly, because whilst you know that there is a TCP port available, you can't see it. UDP has the advantage of being able to completely mask the fact that you've got any TCP or TLS connectivity on your system at all. The trouble with UDP is it's not necessarily that easy to get UDP packets through in a reliable way. So what we have decided to do is to send 2 UDP packets always when a client wants to connect. We send one as an extension to the DTLS packet, which is much the same as an extension to the TLS packet. And we send a second one disguised as a DNS request using some weird encoded URL that you're trying to access. And we only require one of those 2 UDP packets to get through. And this works pretty nicely. Now, I have a system hiding behind here. The admin interface to the system uses standard TLS. And our standard port is on 8443 for doing administration. This would not normally be open to the internet. For doing administration, you'd usually have that hidden. But if we tried to do a curl to this, then you'll see with the typical response that you get when there is some kind of, in this case, NGINX service running in the background. So without any form of SPA, you immediately know what your target potentially is. Now, for normal access to our system, when we are not administrators and we're just users of, say, a client, then we would be connecting on 443 instead. Now, 443 is protected. And therefore, whilst you can see there is something there, you just get a connection was reset. So yes, there is a TCP connection there, but you don't know anything more than that at this time. Now, this system that's running here is not this one, it is this one. And in our global settings, we have check TCP and check UDP. And if I change the system to check UDP instead, that has now changed the status of all the gateways and all the controllers in the system. So they will now only accept connections using UDP. So if I now repeat what we just did here, then it's disappeared. Basically, what UDP has done is we closed the IP tables firewall rule for 443. And unless we receive a valid UDP packet, we do not open the 443 TCP port. When we do get a valid packet, we open it for a time window of 120 seconds, I think it is, to allow a TCP packet then to appear. If it does, we then maintain that connection. If not, as you can see, the system is now hidden. Now that is obviously a very good first step in creating a highly available system. Let's go back to where I was. It should be hiding here somewhere. What this gives us is uncontested connectivity. So we now have the good guys able to connect to our systems, whether they be the policy enforcement points or the policy decision points. And the bad guys typically may not even know that they exist. Next, stateless controllers. Now, it is very important that if you connect, you can connect to something. There's no point in just having NGINX running with nothing behind it. So, controllers obviously are hidden, as I've said, using single packet authorization. So the client will make a request initially to a policy decision point to say, do you know me? The controller will typically check credentials, possibly with a third-party IDP. And if it likes you, it'll give you back something in the form of a token to say, I like you. Now, stateless controllers have a huge advantage. Because they're stateless, they have no knowledge of you being connected to them. They're effectively performing a kind of REST service, and these clients are simply saying, please authenticate me, and the stateless controller gives you back a token to say, here you go. Job is over, connection is dropped. So that first controller now, you can see, is masked again with SPA. It's disappeared. Now, can controllers be truly stateless in an HA world? Not absolutely, but almost. There is hardly any information those controllers need to share between themselves, because all they've done is signed you in and given you a token. Any one of them could have done that. Yes, they might create an audit log to say you've been here, but beyond that, the only thing they did was assign you an IP address, a virtual IP address. So that IP address would need sharing with other controllers, but because those IP addresses are very, very sticky, the likelihood of your IP address changing in a properly set up system is close to zero. So there is almost no information to be shared. So the only other thing to do is you need to make it super easy to connect to these controllers. So what I thought I might do is just quickly download the log files from this client that's signed into one of these controllers just now. Those log files should be hiding in here. And if I look at the application itself that's signed into that controller, then you see right at the top here, 2 lines of great interest. So that was resolving the controller, and you can see 3 IP addresses were returned. Key thing about HA is you don't want to do something clunky like put a load balancer in front of your policy decision points. Policy decision points. It in itself could fail. And because these things don't need load balancing, they just do a job that takes a couple of 100 milliseconds and they're done with you. It's much better to use DNS records and just return 3 IP addresses of the 3 controllers and let the system find one that's available, rather than putting another piece of redundant equipment in the way, and it in itself potentially becoming a failure mechanism. Oh, we've gone back to the beginning of that slide, so let's just whiz through that. So what that gives you is great level of service availability. Any controller can service you at any time, and there's no one in front of it to break down and cause problems. So let me just talk about use of tokens. Some systems probably don't use tokens, but tokens are a super powerful way of creating highly available infrastructure. Now, you've already seen that the controllers will pass a token to you. Well, that token is now passed on to your policy enforcement points, your gateways. And what that does is it tells the gateway that I'm legit and that, if you like, I'm going to allow you to connect to some application that I am protecting. So in this case, you can see that the gateways have read the token and they've passed a secure connection on to my application. Only the one application, I hasten to add, not all 3. Now, I'd like to just show you how powerful that is in action. So what I'll do is we will let's see what I can find here that looks interesting. This guy. Now, I've got a simple system hiding here. Let's just see what's in our simple system. So we've got a controller and we've got a few gateways hiding in my system here. It's all hosted in Google at the current time, so you can see something a bit similar-ish hiding here in Google. So what I'm going to do is I'm going to select, I've got 3 gateways in the system. I'm going to select the 3 gateways, which are the policy enforcement points, if you like, and I'm going to put them to sleep just for now. So I'm going to suspend my 3 gateway instances. So they've kind of gone away. If I go back and look at my dashboard and I look at my appliance health, it'll take a while to load because it's polling those 3 gateways, trying to get their health status currently, and it's going to struggle to get their health status because they're offline, as it says here. Now, I've got this client thing here that's kind of running. Now, I was logged into a collective, but I'm now going to log into the one I've just partially shut down, which is this one here. I'm going to log in as Annie, which is one of my test users. And so I'm signing into my controller, and my controller is still up at the current time. Oh, that's a shame. It's a demo. Let's just check here. No, it should be all right. It's the demo gremlins. You know how the demo gremlins go. Let's just try one more time. Nope, the demo gremlins are at work today. How well. Anyway, what I was going to show you is that tokens, if you like, are sort of creatures that exist even without the system being fully functional. So effectively, once you've received tokens, and obviously from this other profile I have received tokens already, then those tokens can be consumed by gateways, even if the gateways weren't there at the same time as the controller was signing you in. But you will see a bit more of that later. So let me just bring those 3 gateways back up again. So they're all still checked, so I can just restart them. But effectively, the tokens that were passed to my client can be passed on to gateways, and they can be passed on to gateways at any point in time, as long as those tokens remain valid. And their validity is set by other parameters within the system. Now, let's go back to where we were in the presentation. Basically, the use of tokens gives you environmental immunity. So if your demos work, then effectively it means gateways can come and go, controllers can come and go, and as long as you have your tokens, then you are good. Now, context awareness is really important as well. It means that you can make decisions based on pretty much anything. It could be based on the time of day. It could be based on a particular process that is running on your machine. Pretty much anything should be able to set context. Now, because I've got this reluctant system that doesn't seem to want to let me sign in, I would have shown you what that means here, but instead, I will have to show you on another system. But basically, this means that you can adapt what is happening in real time. So typically, a connection will be established for you, the user. But what is important is that you end up with one solution that works for everyone. And that means that your connectivity model needs to adapt to different communities. So if, for instance, you had a look at the way you set up access in these things, you could, for instance, have access control, as shown down here. And that access control is what would define, in part, the types of access that you would be granted. That also manifests itself in policies, where, for instance, if you were to look at this one here, you can see that it's checking for the device OS family being OS X. So you would have a particular community of users that need particular type of access. And if you wanted to change that, for instance, and instead your Windows users needed that kind of access, then you can change a particular parameter to Windows, and from then on, your Windows users would enjoy that type of access. So once you've got a rich language that you can use for defining your access, then it becomes quite easy to actually set up ubiquity, if you like, in terms of having policies to suit all your different user communities. Now, real-time access is something else that is important as well. So this user currently has access to application 2 only. The user tries to access another application, but at that moment in time, the firewall says, that packet you've just sent me, I can't pass that packet at this moment in time. The reason I can't is you don't meet some specific criteria that's set out. Now, this typically could be that the user at that moment in time is required to perform something like MFA. In theory, I can show you this at work. So if, for instance, we look at, say, this guy here, this is a product called UTrack. We use it for tracking tickets in our system. I could click on something and it will open magically. So I'm currently connected to UTrack. Through this client that you saw me connected with earlier. Now, yep, that's UTrack, but I might also, for instance, want to try and, say, ping UTrack as well. Now, pinging UTrack is not allowed, and as you can see, I'm not getting a request granted for ping, and it's popped up to say I need to provide additional authentication. So this is working in real time, and in this case it says please just re-authenticate with the existing provider that you signed in with in the first place. So that's similar to internet banking, where sometimes you're asked to provide your credentials again. And if we go look now, the firewall has now magically opened at that moment in time. And bingo, we have a system that allows you access. You can have various different forms of message, if you like, sent to the user. It can be as simple as this. Just please type in your password again. But there are also other, see what I've got hiding here. Actually, I think it's a shortcut over here. There are also other tricks you can play as well. So here, for instance, is a Windows desktop that you might want to connect to. And again, it's intercepted the traffic. It said that I need to use my security device on this occasion. That's kind of one of these guys. So you, in theory, can insert one of these guys, tap on your security key, and if I was to try again, this time it should actually launch and connect you to a remote Windows desktop. So this is the advantage of real time, and having real-time control provides a lot of benefit from a security point of view, because it means your security posture can become very, very adaptive. Let's go back to here again. Basically, it's very user-centric. So it's designed around the user. The user can self-help. The user can be given messages like, I'm afraid you're on the Wi-Fi network. You're only going to get access to that IP address from the wired network. Please move to the wired network. And then failover is another key thing. Yes, we're talking about HA, but one of the things that we've just seen, user connected to a gateway using the tokens that were provided by the policy decision point in the first place. But there is this big problem with designing HA gateways. If you've got firewalls in your organization, you'll know what it is. And that is that if you have two firewalls, there's one synchronization thing that has to happen between them. But if you've got three, there are now three synchronization things that have to happen. If you've got four, there are now six synchronization things that have to happen. Firewalls that talk to each other do not scale. you never see 4 or 5 firewalls in a cluster because they spend their entire time talking to each other rather than talking to users. However, in a token-based system, the user already has the tokens they need to connect to any gateway that's available on a site. It's a very small change to send a states token back from the firewall to the user. This is something that you can do optionally in this system. It's only a few K in size. So rather than trying to share states between appliances on a massive scale when you've got 5,000 users on a firewall, we simply pass a single state blob back to that user, and it's their states only that's passed back. When the gateway vanishes for whatever reason, that user now has the tokens they need and a states blob, and they can send that back and establish a connection to a new gateway immediately. The gateways have not passed a single byte of information between themselves. And then you can use auto-scaling to bring up another gateway. That becomes available immediately because that gateway has no requirement to synchronize with the previous gateways that were available. Indeed, it arrives, it has 0 firewall rules in it because it's waiting for a user to send them a token. Now, if we go look at this, it's still pinging away quite happily. If I was to look at the client here, then you can see a number of different sites I'm connected to where my gateways hang out. Oops. So I was using, for the ping service, I was using uTrack. If I look at the shortcut details here and I look at the site, you can see that I'm connected to a particular gateway called GotPurple1. So that's the current gateway I was connected to. So if I go to this system that's hiding here, I don't necessarily believe that message at the top of the screen, so we'll just refresh it. So if you look at this list down here, you'll find something, I guess, called GotPurple1 somewhere. It gets easier when you sort it like this. Here's GotPurple1. So this is the gateway, GW, that I'm connected to. And I will edit its configuration. Actually, that's not quite what I wanted to do. I was on the wrong screen. Just find GotPurple1. Here we go. So this is GotPurple1 here, and I am going to reboot it. So GotPurple1 is now rebooted. And you can see there is a request timed out, and then we have continued. So what's happened there is it has just flipped to the other gateway using the token passing mechanism I was just explaining. So that's transparent failover and scaling, which is critical. Now, the last thing I just want to talk about is monitoring. People are in the habit of monitoring really boring things like CPU, RAM, disk, network. If you know what you're doing, it can be worth monitoring those. But when you need to understand how a zero trust system works, it's much better to recognize that, as you've seen, there can be a lot of autonomy in the way components work. It's very user-centric, so you need to think about what matters to users. And maybe you still need to monitor things like RAM. But you should really be thinking about 3 things in Zero Trust. You should make sure your infrastructure is working as you intended, that the functions within it are performing to the spec, and that you're not impinging on any physical limits. So for controllers, sign-in times, Pretty critical thing for users. So why not measure sign-in times? It's much more useful than RAM usage. Your users couldn't care less how much RAM you're using, but they're super concerned with sign-in times. Gateways, okay, users want to pass traffic, so yeah, network throughput could be a really good thing to measure. And there are some other things that you need to consider as well. Like a gateway handling 5,000 users might be making a lot of DNS requests or a lot of lookups to cloud APIs. Maybe you should be measuring those to make sure you're not hitting any quota limits. So, before I summarize, I can just show you the sort of things that we might monitor in one of our collectives. Firstly, distribution of authorizations. I spoke about stateless controllers earlier. You might expect them to be a third each. So it's a super good trick just to check. They are, as you can see, about 1/3 each. Another interesting thing to check is this line here. This line here takes advantage of the fact that we have single packet authorization. We can therefore tell good packets from bad packets. So here, where we're using TCP, SPA in this system, I'm monitoring for unexpected TCP packets that we might be receiving. And you can see average sign-in times here for the 3 controllers, typically less than a second in this case. It may be interesting to look at failed authentications as well, because they could be bad guys trying to break in. But you must remember, with SPA on the front end, the bad guys don't necessarily get as far as trying to break in using some kind of bot. Now, the other thing I can show you is a typical gateway dashboard. You would expect to see similar things on a gateway. Again, you would expect to see a session split, but because I rebooted Purple 1 just a minute or two ago, it's hardly picked up any users since I rebooted it, and the majority of the users, 19 of them, are now on Purple 2 because I just rebooted it. Yes, you should be interested in NICs. Obviously, it's a gateway, but also firewall rules can be super interesting as well. Why are firewall rules interesting? Well, when you're doing everything at the user level, you're creating firewalls on a per-user basis. So you can see here, typically we have in the region of 3 to 30,000 firewall rules active on a gateway at any one time. And that's because every firewall rule is written on a per-user basis. There is no big rule, one for all. Everything is done at the user level. The other things that are interesting is sign-in time again. Why are you signing in? It's a gateway. The reason you're signing into a gateway is because of the use of tokens. So because a token has been sent to the gateway has to validate those tokens and ensure they're valid. Therefore, there is a sign-in process that has to happen. And the other thing, the final thing, if you like, that's of interest would be DNS. So on a gateway with 5,000 users, each user being treated individually, you can end up with a massive number of DNS requests. And therefore, from a high availability point of view, you want to make sure that you're not challenging your AWS cloud with API lookups or your DNS server with record lookups and making sure that you're not hitting some of artificial limit. So, in summary, really, Zero Trust is turning old thinking on its head, and therefore, in a similar way, our approach to HA shouldn't be our traditional approach. That needs to be consigned to history, and we need to think about it in a different way. HA is about providing ubiquitous, which means for everybody, unified, which means just one system, anytime access, which means basically for all hours of the day and night, with minimal management overhead because it looks after itself. So it's not just about the number 2 anymore. Thank you.
Thank you. Thank you. We have really just time for 1 or 2 questions. The first one will come from my side. So we are working at the network level currently, right? So the authentication will happen at the network level, and all the zero trust is implemented, just as I understood from your talk, just at the firewall or the central networking device. This is no agent deployed on the target system. This is where already the user or a computer or a system on the network is already authenticated and comes already to access the network, and then based on the authentication token, either access is granted or denied. Now, the core is, how do you get it working across multiple vendors, specifically if you have to work with multiple firewalls, let's say 2 different firewalls that have to synchronize, or there's no way that can be done and you have to have just a single developer or vendor firewalls to talk to each other?
Well, there's a couple of answers to that. I mean, the Cloud Security Alliance have tried to put together an SDP standard, I suppose you could call it, but it isn't really a standard. So it's a set of ideas. I would almost call it a sort of realization of ideas. And those ideas in themselves go some way to kind of establishing a standard. They, for instance, at one time were looking at SPA and seeing whether the types of extensions that you might want to add to TCP to turn it into an SPA type of packet could be standardized. But quite a lot of vendors went their own way and did their own thing, including us. So arguably, there isn't really a standard that you can use today for that purpose. But equally, ubiquitous use of a system should replace things like a lot of firewalls. They wouldn't have to work with network firewalls. Some people do keep network firewalls in place because they're very good for bulk connectivity. But when it comes to the user connectivity, it could be better to jump ships and choose an SPA vendor and work with them just for your user and device access.
All right. If there is any question from the audience, I would gladly take it from here. Where's my microphone guy? Okay, we've lost him. But for sure, do ask the question. I'll try to repeat it as well.
Actually, I have 2 questions, if you don't mind.
Let's go with one.
Okay. The short one is, how do you enforce the policy for the user? Can you do the policy regards to user posture? Wasn't clear.
Yeah, you mean device posture, I assume?
Yeah, device posture.
Yep. Well, because we have both agent and agent-less ways of connecting, if you have an agent-based way of connecting, then that agent is able to interrogate the local device and can pass back information about the device. The other way of doing it is because many organizations now have cloud-based services for device posture checking. So our policy decision point can make API calls to say, one of the vendors that support device security, and just say, for this device ID, could you please tell me the status of that device or some characteristics of that device? We would then consume that information and adapt our security posture based on the information we've received from somebody like CrowdStrike.
All right. All right, with this, Jamie, I thank you for coming over. And there's a small token from CertLV as well from my side.
Well, thank you very much for having me.
Thank you. Thank you so much. With this, we are going to go on a very short break, which is 30 seconds. So stay in tune with us because the next speaker is just coming up in a very short bit. All right, welcome back. An unexpected, short, very brief pause between the two speakers. I have already here on stage Mikko, who is a CEO and a researcher and a very good friend of mine. He's here to talk about how can you break out from an isolated environment. Please do tell us. Thank you.
All right, thank you. It's great to be over here, and this is my first time over here in Riga in general. So far, everything is good. Nice place to be. But at first, I want to give a big round of applause for Bibi and all the CERT LV team to arranging this great event over here. All right, so today I'm going to talk about escaping from the isolated environments. So what this means is that we have started to company SensorFu back in the 2017, and during that time we found out that there's quite a lot of isolated, or before that we've learned that there's quite a lot of isolated networks still out there. But today I'm going to talk about you a bit about the higher perspective, where we are coming from and why the isolated networks are still rather important, and then quite quickly we dive in deeply into the reasons why the network isolation and different systems with the isolation might fail or cause some troubles with the isolation. We have some more generic cases, so I would say that which are the most common cases related to especially to the network isolation, and then I have a couple of really technical specific cases which might be interesting, especially for you guys who are really into the technical details. So, my name is Mikko Kenttälä. I'm a founder and CEO of SensorFu, but I have a long history in the technical field. I've been always hacker also. Since the high school, I've been playing around with the technology, networks, and Unix systems. I actually, in the high school, I think the first thing what I learned from the hacking was to actually how you can sniff some traffic from the hubs and learn if there's a telnet connections, you can get the username and password from there. And that was really something during the high school. And since then, I've been always interested about the cybersecurity in really technical terms also. I have a past of doing technical security audits, meaning that we actually went and tested some of the security policies what the customers may have. But also we've been doing some pen testing, blue team, red team exercises, and so on. And I'm, as a hobby, I've been doing also some vulnerability research, which is I'm going to talk about more also in tomorrow, related to some of the Mac OS vulnerabilities what I've found. But today we are talking about the network isolation and the isolation in general. Even though we had a good presentation beforehand about the Zero Trust and it's coming more popular, we are still heavily relying to different type of isolations and air gaps. And those are for many places, those are the security controls which are covering the OT infrastructure, banking, healthcare, secretive networks in governmental level, and so on. So it is still heavily used in many places, and based on our experiences, when we deploy our products and based on the experiences of doing the technical security audits, most of the times there's still slip-ups related to that network isolation. Just really shortly, because some of the technical findings what I'm going to cover is related to our product. I just quickly show the base idea how the product works. We have a component called Beacon, which is deployed to the isolated network, and it tries to call home automatically, continuously, all the time, with multiple different techniques. So some of these findings, what I'm going to cover, is related to the things what our product has found over the years, and some of the things are related to the research what we have done while developing this product. A bit about the reasons why the network isolation is important thing. The fact is that the network isolation and segmentation is still heavily in the foundation of the cybersecurity. So Gartner did this type of security pyramid to map out the different practices and security policies and put it in the way that you can see that some of the things are maybe more critical and more in the foundation of the cybersecurity. And I think if there's some managers around here or in the audience, I just want to highlight that many of the topics over here are quite boring, related to which are in the really in the fundamentals. But that's the thing where most of the slip-ups actually happen, and most of the attackers can leverage that. And it doesn't mean that you don't need to pay attention on the things which are on the top of that pyramid, but it more like shows that those are really valid and important security policies and practices. But in general, it means that if you have a huge slip-ups or caps or misconfiguration in the foundation, those won't help you much because they are covering some of the things in the top of the pyramid. And there's a couple of examples. For example, some use cases, Rob Joyce in 2019 tweeted about the specific case where one nuclear plant was connected directly to the internet because someone inside of maybe the employee or someone who had access over there decided to connect one of the systems directly to the internet, because he or she wanted to do some crypto mining over there. Maybe there was a cheap electricity available in the nuclear power plant or something like that, which made he do it. But these things really happen when there's some silly thing which basically break the security boundaries in that network. So one good sales point also for the zero trust networks, because these things really happen. And this is the case what you most likely know already, but I just want to highlight some of the things. So there was a cyber attacks in Ukraine in 2015, which led to the power outage in certain environments over there, or certain areas of the country. It lasted a couple of hours, took down 30 substations, and obviously there was a nation-state level attacker behind it. But there was luckily it took only several hours because they still have some manual switches in place, so they can do, even though if they lose control to the automation side of the things, they are still able to recover in some reasonable manner to do the manual switching over there by the switches and cranking those up and down. But that's not always the case in all of the critical infrastructure network. But there was one highlight which was highlighted by the SANS, that the proper network segmentation was the #1 recommendation from the architectural point of view in this case. Obviously, there was other suggestions too, which are once again one of those rather boring topics, which are more about how you handle the things in practice and how you actually execute those policies in a way that those will help you in the scenarios where you have issues on your network. There's one more example from this overview, is the case related to the Norsk Hydro. Norsk Hydro got hit by the ransomware case, which was basically able to affect all of their IT infrastructure. So all their employees were affected to this on their IT side. And I think they are the world's biggest aluminum provider, so it was obviously huge case, but there was a success story behind it. And I want to highlight, and I like to use this example just because of that fact that once we have a story where there is actually a success story also behind it. So that CryptoLocker was not able to distribute itself to their core operational network where the actual production is going on when they are pushing the Aluminum to the next level and melting it down and so on. So CryptoLocker was not able to affect that, and they say it by themselves that exactly was because of the network segmentation and separated administrated domains. So those two things, they think that were the most important things. All right, so let's dive in to the more on the technical side. Previously, if you're into this topic, we've done another presentations related to this network isolation scenarios, different kind of scenarios. We did a presentation in Disobey, which is the one great hacker event in Finland. You should all join. And we did presentation over there where we showed that how you can escape from the host-only network virtual machine in one system and take the connection from that host-only isolated system. You can take a connection towards to the different machine in that in same Wi-Fi. So even though you are inside of the virtual machine in host-only network, how you can do it. You can see the demonstration from YouTube related to that. And I think for the techies, especially, there was another great example done by my colleague, which was related to the covered channels in the DNS cache. So I think some of you have heard about the DNS tunneling before, but this was something different. Typically, when you are using the DNS tunneling, you have to have the registered domain names, but my colleague was presenting the way to leverage the DNS cache in a way that you don't have to have the registered domain names. You can just use the negative cache from the DNS system in a way that you can leak out the data if you have a DNS available. So let's dive into the network isolation topic. Typically, if you talk with someone about the network isolation, and if you try to draw a picture that how it actually looks like on the topology view, this is something what you end up. Obviously, quite simplified version, but anyway, this is everybody's idea that you have the isolated network. There's one firewall and router controlling the connectivity between maybe the office network or not that isolated environment, and from there you have a connectivity towards the internet. However, in reality, when you start to map out that kind of environment and all the components over there, it actually includes multiple different things. One of the things is the spare gateways. Those may be hot swappable gateways which will jump in if the main primary gateway will go down and so on. But it might be that it's already ready to route all the traffic. So even though you have the firewall and router in place, there might be separated devices which are capable of routing the traffic, which are not active in the network, but those may be able to, you can maybe use those even though those are not thought to be used. Then, one thing which is really common is that you have some shared services between multiple networks. So in this case, like for example, NTP and the DNS, for example, are the shared services. Quite common case that you have both of those services available from the office network and isolated networks. And you can leverage out those. So if you are in the isolated network, there may be a way to leverage the connectivity between the DNS and NTP and use those as a jump host towards to the other networks. Then there's many times, especially in the OT world, there's so-called support gateway, which is installed to the automation environment, and this is typically done by the manufacturers of the automation system. So they deploy so-called support gateway to that isolated network, and it provides alternative avenue out from that isolated network, but also into that network. So many times these may include like 4G devices and so on. So they have a completely separated connection out and in from that isolated network. So once again, it starts to be much more complicated in that sense. And then again, there might be users in the isolated network who decides to connect one of the systems directly to their phone, maybe for charging the phone or getting the tethering and the internet connectivity up to spend their time. If they are sitting in the monitoring room or something like that, they might get quite bored. Luckily, this doesn't happen that often anymore, at least in purpose, because most of the persons have a decent mobile devices where they can spend their time for browsing a web if they are sitting in the monitoring room. Even though it might be against the policies, but these things still really happen. Then, the most common reason what we see with our product, why the network isolation is failing, is the DNS. So I think there's a couple of reasons behind that. I think that's the most, might be most common idea which comes to everybody's mind, that the DNS actually might be working in most of the time. So even if we are talking about the critical infrastructure and the factories in the OT network or some other isolated network, DNS is surprisingly often available. And the thing with the DNS is the fact that you can use it in a way that if you watch the topology picture as a defender, you don't immediately figure that out, that, oh yeah, you can actually use this DNS to make direct connections to the internet, because you can do DNS queries. Those DNS queries go all the way to the internet, and the information inside of that message will go directly to the internet. And that's so easy to miss, and this is something what you need to know. So it's hard to figure out it by yourself, I would say. Many times, the organizations need to deploy some sort of single sign-on. So for that, they use AD. So they need to have a connectivity towards to the AD. And the AD, at the same time, is DNS server. So that's one of the reasons why most of the time DNS is working. Also, routers can be DNS resolvers, so you are, from the firewall point of view, you are not taking connections towards to the different networks, you are just communicating to the router, and if there's a DNS resolver, that resolver will do the job and query all the questions towards to the internet, if that's possible. And quite often it is. And I think the main thing over here is that it's so easy to ignore the fact that the DNS is available. So let's go into one specific scenario, which is also quite common scenario, what we have seen over the years of doing things related to the isolated environments. So in the industrial network segmentation is the #1 strategy to defend it. So typically, when you discuss with the owner of the OT environment, pretty quickly, if you ask at how you have taken care of the security of your organization in the OT side, the most common answer is the network isolation. And most of the best practices actually promote it, and sometimes it's even requirement, and in some countries even in the it's coming to legislation that these environments should be isolated. And if there's mistakes done over there, it will have huge consequences. So the best practice in that world is to use the Purdue model, which basically includes multiple layers of defense, typically, and the best practices are basically following that. So the Purdue model actually includes multiple layers, and it's not built for the security, but many times this is also used as a guideline for the segmentation and the controls and the network isolation over there. So once again, we start with the network topology. If you look at that, there's multiple firewall routers between each of the zones over there. So the fundamental idea with the Purdue model is that you have a normal office network, which is the enterprise zone over there. Then you have an industrial DMZ zone, which may include some shared services which are used by the other systems inside of the factories and so on. So PLCs and ICS devices are in general using those services commonly. And from that network zone, you typically have some connectivity towards to the internet, although it may be restricted. But the idea is that it's shared. It includes shared services for the other bottom levels over there. Level 3 network typically is the site operation and control level, so you have like monitoring rooms and so on in that place. And then you have the cell zone or area zone, which actually includes those PLCs and the sensors and devices, and those should be also contained to the separated networks. Obviously, not always these are not implemented in completely. Actually, more often you have from the network segmentation point of view, you have these level 3 and level 2 networks are kind of combined together. But still, it's something similar. But once again, in reality, when we start to dig up that how this actually looks in a practice, first of all, you don't have 4 firewalls. And I'm not encouraging you to use 4 different firewalls. You might have 2 firewalls. I think that's more common. And with these, the basic idea is that you have the one firewall router, which is between the office site and the public internet site, and then you have another firewall, which is controlling the different sites and the actual stuff in the OT network in general. So in the factories and so on. So you have 2 different control mechanisms for that. Then we were actually visiting, while we were doing research for network testing, the network isolation, we visited the University of Tampere. They have an automation laboratory, including all kind of devices all the way from the last 30 years or something like that related to the OT network. They have also implemented like a Purdue model in a way that they can teach them that this is the best practice and how you should roll on. So in that case, we had the fundamental idea is that you, in the bottom level at the firewall, it should be able to block all the traffic from the level 2 and level 3 network towards to the internet, and because that segment should be quite isolated also from the both directions. But what happened in this case? We sent ICMP echo request towards to the internet. There was one tricky thing related to it. So, and the why it was actually working, but we sent that kind of package, and the router received it and was a bit confused about it, and was thinking of that, what should I do with this packet? And the trick related to this was the fact that we told that this packet is actually coming from the subnet, which is completely different subnet where we are at. So we were at the level 2 network. During that time, we sent packet what seems to be coming from the IDMZ. And since the same firewall is controlling the traffic, it should know better, but it basically, because it didn't have anti-spoofing enabled, or it didn't have a URPF, which is unicast reverse path forwarding, enabled, and because we spoofed our source IP address, was actually gladly allowing that connection to go through, because it mapped out the source IP address, which were matching to the IDMZ zone, and with that, it checks access control. It will check the access control list and found out that, okay, this kind of traffic is allowed from the IDMZ zone, and it will just push the traffic forward towards the internet. And because that internet-facing firewall doesn't have any context of the where is this spoofed IP address or anything. And it's generally IDMC is allowed to talk to the internet. ICMP was allowed, so it went through. So even when we started from the point of view that we had the 4 firewalls and multiple layers, sometimes the things what you may find is actually quite straightforward. The funny thing or sad thing, depending on the point of view, is that this spoof IP technique is introduced basically at the late 90s. So there's nothing new over there. Most of the firewalls and routers have the capability to stop that with the anti-spoofing or URPF, and it takes 5 to 15 minutes to enable it. But it is not enabled by default, and that's the thing, why it works most of the time. And this is important for maybe 2 kind of use cases, what I can make of at least. One thing is obviously if you have something secretive data in your isolated network and you want to keep that in, this may be the way to leak it out, and that way you have a good way to evade some of the controls in that network. But another thing, especially in the automation side or OT and the critical infrastructure, is the fact that you can use this other way around also. So you may be able to send UDP traffic directly to the PLCs from the office network or from the IDMC zone, which are much more likely to get compromised in case of some kind of like a cyber event. So these things still may occur, and it, especially in the OT world, it's quite common to use protocols like UDP, so you can just send a malicious traffic for some of the sensors or the PLCs over there. All right, let's move forward. I forgot to mention that this is the spoof IP test is the second most common thing which is found from the organizations, even though if you have a multiple firewalls and plenty of controls in your environment. So it really still, unfortunately, is a thing. Then, continuous testing. This is also important case in the sense that this is also, I think, Rob Joyce once said also on one of the presentation for the defenders of the network that how you can stop the nation-state players to getting in is the fact that if you are able to make sure that your security policies are in place all the time, continuously, it might be the key thing. And we have found it out other way around. So when we are testing continuously the network isolation, we have found out some interesting cases. So every now and then, the configuration may change, and there might be slip-ups happening, or there might be issues with the devices. And in this one specific particular case, we had a setup with one of our customers. We're running it on the specific remote automation environment. They had a remote site over there. They had VPN connectivity between their headquarters IDMC zone. So, and this is something which is rather common. If you have multiple remote locations, you have some sort of tunneling between the services or the remote sites. So they had a setup where they had that internal network, the remote site was connected to their IDMC with the VPN solution, which was relying on the 4G connectivity. We had a beacon deployed over there, and it was running over there like 2.5 months to 3 months or something like that. And all of a sudden, beacon called home, and some of the traffic were able to go through for some time. So our customer got the notification. They started to dig in that what is actually going on and what was happening on that environment during that time. It turned out that they did actually some updates to the environment, which is a good thing during that time, and pretty quickly was able to reproduce the issue. And the issue was that whenever, if you reboot the router over there, for a while, it didn't have any of their customized firewall rules in place. So it was working around a minute or so, completely without the firewall rules which were done by our customer. And it turned out that there was an issue in the ABB's Arctic Wireless Gateway in the circumstances where if you reboot the system, there will be a case where the user-made configuration is not loaded immediately, so the internet will be available and open without the restrictions for a while. The same applies if for any reason the VPN tunnel goes down, the same thing will happen. And this basically allows if you have an infection on the site, and during that time all the connectivity will be available. So we have multiple similar cases related to this, most of the time related to the configuration changes and so on, which we have seen over the years to happen. And so the third most common reason why the network isolation is failing is something related to the changes in that environment. And you can only find those out with the continuous testing, and those are basically not visible all the time. So the topic was to talk about the isolated environments. So this finding was actually coincident for us, but it may be interesting from multiple points of view. So isolated Windows, which is able to call home even though it's in the restricted environment. So this is a real case, also happened during we were developing the Windows application related to our product. But this thing happened in a way that I have my hobby related to the vulnerability research, but also for sometimes I do a bit of malware analysis. So I have an isolated network at my home laboratory. And I had already like Windows running in there, and I had our Beacon running over there as a virtual machine. Everything working correctly. This is basically the firewall rules that I had on that firewall and gateway, basically block everything immediately, and with the only exceptions that from that network you are able to take connections towards to the file server, and then you have a connectivity to the Microsoft services to getting the updates for the Windows system whenever I need it, and then I had the DNS allowed for my local resolver. And the issue was not the DNS in this case. So I got the binary from my colleague related to the Beacon, which I got the binary for the Windows. I installed it, and it went well. That was one of the first versions of the build, so I was surprised that everything went smoothly, and the guys were done a good job in that sense. But all of a sudden, I got the notification that Beacon was able to call home, and I was wondering what the hell is going on, because I already had an isolated network. I have a Beacon running over there, testing the network isolation all the time, and it's working as expected. No connectivity out from there. So the leakage looks like this. Then I went to check out that, okay, Beacon was able to call home, and pretty quickly figured out that this is not my IP address. The receipt from address is not mine. So I get really paranoid about what is going on. Is someone compromised my environment? Is he or she stealing all the data that I'm uploading over there? Or what the hell is going on? And the guys pretty quickly figured out that this is coming from the Microsoft. So now, next level of paranoia kicks in. Why the Microsoft is running my binary, and why the connectivity is coming from there. I started to check around that is this same IP range for the Azure and so on, the services what the Microsoft are providing, but no. And it turned out, after a while, of a couple of tens of minutes of stressing out about what might be going on, the reason was this. And the fact is that if you have a Windows on your system, as many of you most likely have, there's an automatic sample submission, which is enabled by default, which is basically capability to upload all the unique executables to the Microsoft. And what Microsoft will do with that is that they run it automatically on their sandboxes and do analysis for that. The cool or troubling thing was the fact that Beacon was also able to call home from that sandbox and made it all the way through. So in this topology, the thing was that I had allowed the connectivity towards the Microsoft, and what happened was that the Defender sample was submitted to the Microsoft, and they ran it on the sandbox, and from that sandbox, Beacon was able to go home, and it was really, really surprising for me. So this is quite a rare case, but if you are wanting to build some scenarios or something like that, there's also research done before related to this topic and proof of concept. Unfortunately, I cannot remember the name of the guys or the organization who did it, but you can leverage this technique in a way that you have if you have infected some of the systems on that environment, you will write the secretive data to that executable and make it so that when that executable touches the disk, including the secretive data, what you want to upload, the executable will be transferred to the Microsoft if you have that connectivity available, and Microsoft will run it on the environment which have a more capable internet connectivity, and with that you are able to get and receive the data inside of that executable. Bit far-fetched for the average criminals, but maybe not for some other organizations. But that was really interesting and also technically funny case. And by the way, later on, we needed to change the way how we deploy the Beacon, because it turned out that it's not a good idea from the security product point of view if you are receiving unique binaries all the time with the new versions and so on from us. So all the bells and whistles are screaming all the time if you have a unique executables. In our case, the configuration was embedded to the binary, and that's why those are different every time and for every users. So we changed it for the more common deployment method. All right, since I have some time left, there's one more thing. This is quite technical. I try to go it through rather quickly to make it on the deadline that the BB won't kick me out. So this is about the bounce attack. We talked about this also in the disobey previously, and this was exactly the technique what we used to escaping from the virtual machines, which are in the isolated network. But I found out the new ways to leverage this attack quite recently. So I don't know how many of you are familiar with the bounce attack, but this is not a new technique in that sense, but I will refresh your mind. So the fundamental idea is to use the things what we can control. So in many cases in the network layer, we can also control things which are not most of the time controlled by the users. So the fundamental idea in this picture is that the Alice is in the contained, isolated environment, which is controlled by the bouncer, and she wants to communicate get the message out to Bob. So how she can do it? She will say to the bouncer that, "Hi, I am Bob. I want to say, how are you, to Charlie." The bouncer forwards that information to Charlie because that's something what the bouncer is allowed to do. And then Charlie receives the message and figures out that, okay, Bob is trying to send this information for me, but I'm not allowed to answer for that. So for that reason, I answer to Bob that, "Hi, Bob, Charlie is not available. You cannot say, how are you, to Charlie." So you fool the bouncer and the control mechanism to think about you as someone else, and they try to reply to that someone else, and actually at the same time they forward the traffic towards to the owner of that information or target of that information. So we found out the bounce attack, or I found out that there's a possibility to leverage this bounce attack in the AVDL network. I think most of you might not be aware that what the AWDL network is, but let's have a quick question. How many of you have an Apple device, iPhone, iWatch, iPad, MacBook? Couple of you, yeah, maybe half or 1/3 of the audience have an Apple device. So the thing it might be that you don't know, but our devices are communicating continuously or every now and then between each other, all the Apple devices. So my laptop is talking to your watches and your phones every now and then. And this happens so that Apple has an ad hoc wireless network for Apple devices. It will be triggered by the Bluetooth low energy. I broadcast that, hey, I have something to say for everybody, and your devices will go online on that AWL network and say, do the introductions to each other and maybe share some ideas that what kind of services there may be available. So I was thinking that can this be used for this kind of scenario where you have a high security network which is air-capped, so there's no routers or connectivity out of that environment, but you have infected MacBook in that environment, and someone walks in with the phone on his pocket. And can we leak the data out? And here's a demonstration. I will talk this through also. So I was able to find out that in this environment, which is used by AirDrop, AirPlay, Handoff, others, we were actually able to get the data out from that environment. So you have the isolated network, you have the infected MacBook over there with the secrets, and then someone walks into that, near to that environment, and the iPhone and the MacBook will start to discuss between each other automatically. MacBook finds out the new device in that network and start to do probing to get the connectivity out and a bit more information, and can push the data towards to the internet. And the bounce attack was used in this case. And this is basically how it looks like in my demonstration. Hopefully you can see it. On the top terminal is the MacBook, which are in the isolated network, and on the bottom is the terminal, which is actually at the server at the internet. So now we are receiving the Mikko's iPhone come to the next to the MacBook, found out that there's a certain information, but also public IPv6 address, which is related to that device. And with this information, we can send the traffic, which is specifically crafted in a way that when the phone receives that information, we can send the secrets towards to the mobile device, and because it's once again detecting that, okay, this is coming actually from the internet, so I am actually answering this data towards to the internet, so it's basically redirecting the traffic towards it. You see more technical picture now, and I can actually show it later on also more clearly. But this way, the trick is to fool the phone to think about the connection was coming from the different side. So over here, in the really packet layer, in the details in the packet layer, if you look at when we have the MacBook over there on the left side, the layer 2 address was leaker's the original MAC address, and the destination was the AWDL interface in the phone. So MAC address is related to that. But the layer 3 address is actually not the same IP address what the AWDL address was. So we use source IP, which is actually the server at the internet in the layer 3 level, and the destination was the iPhone's mobile interface IP address. And this is the important part. That way, because we are in the layer 2 level, the connect will go smoothly into the mobile device, and later on in the network stack, it will be resolved. The IP addresses will be resolved, and the phone thinks that that traffic was actually coming from the mobile interface. So it's okay to send the packets towards to that direction. And that will actually happen. And that way, the receiver will get the secretive data from that isolated environment. All right, so some conclusions. DNS works most of the time. So that's That's really how it goes. Unfortunately, malware writers actually know about that too. That's why they are using DNS as a command and control channel so often. Anti-spoofing is not supported or enabled by default, and that's why it's still happening, even though this is a technique which is known to be work since the 90s. Issues with the firewall access control list, so you have forgotten test rules, too wide allow rules, some misunderstanding. For example, if you have configured the network stack in the cloud services, if you add block all connections to outward connections, it actually won't stop all the outward connections. For example, DNS will still work. Software updates are needed, so that reason there's a wide rules. This is important to remember that switches, routers, and cabling is also part of the isolation. So sometimes someone might connect the cable the wrong place, which means that the two networks are joined together. Everything might work smoothly, but you have two networks in one layer 2 network. These things really happen. So that's not helping with the network isolation. One interesting thing is also that we normally talk about the protocol, IP protocols, ICMP, UDP, and TCP. But there's actually 140 different IP-based protocols which are over there. And sometimes when you do the default blocking policy, some of the firewalls actually suggest that this should be it. This is enough for doing the blocking. If you block these protocols, it is enough. So you have an idea that you have blocked everything, but that's not really the case. You need to dive into the details and find out that, oh, I need to do this and this more careful configuration to actually make the blockage to happen. So there's protocols like IPsec, some routing protocols, and so on, and some tunneling protocols. IPv6 in general is misunderstood and misconfigured, so if you just don't pay attention for IPv6, it doesn't help. It might be still over there. And another thing is that in some firewalls, you have a different table for IPv6. So you have IPv4 rules, which need to be configured. Those might be well sealed and everything is in place. And you think that we are not running IPv6, so it's completely forgotten. But there's no like a default blocking policy, which might mean that IPv6 is completely allowed. And as we saw, ICMP can go through all the layers. So if you need to have a connectivity, that might be a really good option for that. But all right, thank you.
All right, thank you, Mikko. Let's have a chat. So you clearly elaborated, and I think also the previous speaker also told, and I think the upcoming speaker will agree on this, that isolation is no more possible. We're talking about just the isolation, segmentation. Segmentation is now, but we have to focus. Having like air-gap networks, it's not the thing anymore. Now you mentioned multiple approaches here. You mentioned the DNS, spoofed IP, UDP, and on your last slide, you kind of thought of all the other methods and explained all the other methods quickly as well. So would rogue, unsanctioned devices, forgotten devices be as a pivot point? And have you encountered those as well in your challenges? Definitely,
yeah. So I think that is like I said, I've done also red teaming and the penetration testing. So that's definitely the thing what we try to find out, because it's a forgotten device someplace which is basically not configured as it should be. There's no cases what I can share like real cases from the customers, but it is really true that that's the case, and especially that happens also with the support gateways in the OT environments, which surprises me that you have your bulk devices which are deployed to the on-site, and it might include that you have an alternative routing point also. So that really happens.
Right, but the solution that you have evolved and developed, that uses multiple techniques to figure out how to get out, right?
Yeah.
How would it identify? Does it do also the asset inventory of what is visible as well?
Yeah, good point. We are actually not collecting the asset information. We do it in a way that we have opportunistic tests which are running continuously, and if something goes wrong on the isolation, you get the notification. Then it's up to the customer to decide was this something what you're expecting or not. Many times it's something what cuts you off guard, but sometimes you need to have you only have the restrictions in the place. It doesn't mean that it's fully isolated, like you said. So it's up to the customer to decide that how well they want to control it. But most of the time, most of the customers actually want to do good controls. So they want to have an access list, which is really the access list in the sense that only these connections should be going to the outwards or the coming in.
Right. Have you tried to abuse also industrial control system protocols to your benefit as well?
Yeah, well, on the research side, not on the product side, because there's a high risk of something surprising to happen, which is not like the idea, in the sense that our product should be running on the production environment all the time without causing any troubles. So in the research side, we have done some things, but not on the product itself, because there's a risk for causing some troubles.
Right. And the solution that you've developed, it verifies if it is, in essence, possible to leak information out, if I understand. Not necessarily to provide a control mechanism over the information, not necessarily, not always is going to happen. It depends on multiple conditions and also the protocol in use. So what about having an impact? Would that be possible, like breaching the isolation and also having an impact as well?
Yeah, so typically what happens is that if you test it from the inside point of view, you find out some misconfigurations. These same issues might go other way around, I would say. But when most of our customers, they actually have multiple layers of the protections. For in that sense, they are also worried about the testing, the network segmentation inside of their organization. But also, many of the places where the beacons are actually running are the places where the customers actually want to control the outbound connectivity. So for them, it is a big impact already that if they find out some misconfigurations. And this comes because they know they have had, many of the customers have had cases where the potential malware have came in via USB stick or something like a with a malicious laptop or something like that. So they are really aware about that.
Right, and I think one of the questions that I might ask to Jamie after the session is over is how easy it is to implement zero trust in industrial control systems, if that is possible at all, but let's have a discussion after that with you. Are there any questions from the audience directly to Mikko? If not, catch Mikko during the session. He'll be here. He'll be also speaking tomorrow. He'll be explaining about how he hacked some things, but that is already left for tomorrow. Thank you, and this is a gift from CertLV. Thank you.
Thank you
so much. With this, we have 8 minutes of well-deserved break. I'll see you back here, and we will venture into the world of ICS exploitation and ICS vulnerabilities. See you very, very soon. So welcome back. The ones who are here, it's good to have you here. The day is carrying on. Now, to link together the things that we've already discussed, we have talked about zero trust. We've tried to go into the explaining what isolation and segmentation is and how to break out of this. And we've barely touched a little bit upon industrial control systems. Not from this perspective as our next speaker is going to present. Now, I have on stage Kasper and, well, the crowd, both here and online, is yours.
Thank you so much, Dr. B. I've been looking forward to this opportunity for a long time. My name is Kasper Bladt, and I'm a senior IT/OT cybersecurity consultant with the company called ICS Range. ICS Range is an online interactive industrial control system security training platform. That was a long sentence. In the past, I've been doing control systems for industrial refrigeration and embedded controllers for C and C++. Parallel to that, I've been competing in different hacking competitions, like in 2016, where I qualified for the Danish Defense Intelligence Services Hacker Academy, and later for the National Hacking Team's semi-final in 18 and 19. I'm going to start with a quick overview of some of the aberrations I'm going to use in this presentation. IT, or informational technology, we all know. What I understand with IT is enterprise systems that handles data instead of processes and physical stuff. It handles data, information, users, and permissions. Some say that operational technology means, some say that OT means operational technology, but I don't agree. I say it means overtime, but there we are. That interacts with the real world and processes instead. That could be like robots controlling the storage facilities in industrial or commercial contexts. It could be conveyor belts in a factory, or it could be the industrial refrigeration plants that I talked about just before. Then there's the magic aberration called ICS that are used a bit so and so. Industrial control system, it means, and with that I mean the actual PLCs or controllers or modules that sits on the actual plant controlling the refrigeration cycle, as an example, or controlling the motor that runs the conveyor belt, or controlling the actuators in the arm in the robot that in the before mentioned storage facility. Here's a quote which again just highlights what I just tried to say just before. The difference between enterprise security and ICS security is the data and the servers, and the facility to safely and securely operate whatever this industry or commercial thing is doing. What I'm here to talk about is this device. It's called an Moxa Nport 5110. It's a so-called serial device server, which purpose in life is to connect to these PLCs or controllers or RTUs or whatever that could exist in these ICS plants. It could connect to these devices, uses different serial buses as RS-232, 485, and even some of them can do 422. On the other side, it will do Ethernet in any way, RJ45, fiber, some still uses M12. But the thing is that they connect to an IP network, So you through an IP tunnel, so to say, you can connect to this serial device, and that serial COM port will actually show up on your Windows PC as if you were physically connected to it with the serial adapter. We in ICS Range have been testing this device a lot the last half year or so, and there's a few reasons for that. One of them is that there's a lot of them in use around the world, especially in Europe, where they are in use in everything from refrigeration plants, power plants, wind turbines, and all sorts of other stuff that that exists. My colleague, he usually says that that either you know that you have Moxa devices in your network, or you don't know what you have in your network. 6,174 is publicly available on the internet, according to Shodan. And to IT people, that might not seem like a lot. Like if you were to look up some Cisco device or something related on Shodan, you would get way more results. But in this world, that is really much. And when you're comparing to some of Moxa's competition on the market in serial device servers, they get like 30 hits, or one of them got even 1,500 hits. So it's still way less than Moxa. The thing is that this number should be 0, because all of these should be hidden from the internet. They shouldn't be directly accessible from the internet, and that is one of the things I will get into in a bit. I'm going to talk a bit about an attack on the Ukrainian power grid in 2015. This slide might seem a bit familiar to some of you, because it looks a lot like the one that were presented in the presentation just before me. So I'm going to try to just fill in what else I had to say about it. This whole attack was a combination of a lot of different attack vectors. One of them was a ransomware attack that Russia launched on Ukraine. Meanwhile, they launched some denial of service, distributed denial of service attacks on call centers and TV stations, while they deployed an attack on these Moxa endport devices using a configuration leak in them. So they could access these Moxa devices. I don't know if it was directly on the internet or they had some kind of internal access, but they could access them via IP network. From a bug in the Moxa firmware, they could, through SNMP, they could leak the whole configuration wherein the administrator password were in clear text. With this clear text password, they could, using the Windows tool that Moxa supplies, they could log in to the device, they could attach the serial COM port to their computer, and they could take control on whatever was in the other end of that serial connection. In this case, it were some IEC 104 controlled breakers, or like big relays that were actually controlling substations in this power grid. So they could actually just turn off substations one by one, and all in all, about 250,000 people in Kiev were without power for over the Christmas. An interesting thing about this power grid attack is that it is the first publicly acknowledged cyber attack on a whole nation's, like, state-sponsored attack on a nation's power grid. That is one of the reasons that we chose to test this Moxa device. Is also that we wanted to use it for educational purposes. Again, ICS range, we do interactive training in ICS security. And we thought that with these previous attacks on the device, which were disclosed and there were proof of concepts publicly available, and it seemed easy that we could take some of these attacks and use them for educational purposes. But instead, we found our own few vulnerabilities in this device. So there are two I'm going to mention here. There's a buffer overflow one, which we so far have succeeded in using as a denial of service attack, which means that we can, from remote, we can turn off the device, which would practically mean that the 6,100 and so much devices that we saw earlier that were all online on the internet, we would be able to turn off with a simple script. I'm sure that there will be some people out there who wouldn't appreciate that. There's also a so-called out-of-bounds write vulnerability, which is still in responsible disclosure. I'm not going to talk much about that, but that is also basically just a denial of service vulnerability, which allows you to write to more or less arbitrary pieces of memory around the device, the device's processor memory. Then I promised our dear Dr. B that I would provide some extra spice for this presentation that I haven't talked about before. And the thing is that a few weeks ago we realized, my colleague Jens realized that the attack that the Russians leveraged in the power grid attack in 2015, which enabled them to leak the whole configuration, it were never fully patched. They removed the clear text password from the configuration, but you are still able to leak the rest of the configuration, like the private SNMP community string. And that is just as bad as the password, really, because you can also use that to set values here and there. Buffer overflow is the vulnerability I'm going to talk a bit about. As I said, we have proved this to be a denial of service vulnerability, which means, again, that we can power the device off. But hypothetically, we could use this to run our own code on the Moxa device. And I'm going to talk a little bit about how we could maybe do that. This is how the memory looks like, the stack memory looks like in the CPU of such a little ARM processor that is running in a Moxa NPort device. Basically, we have on the left we have a block for local storage and the parameters in the current function that we are running in. From that function, we are going to call another function, like imagine plain C code where you are just calling a function. What ARM32-bit would do as the very first thing is that it would save some of the CPU registers on the stack in the memory so it could pop them back again later. The registers that are saved are, among others, the linked register, which is very interesting. I'm going to talk a bit about. There's the frame pointer and a bunch of other registers. And then we get to the new function's own local storage, and the stack grows further down. If that function were to call a new function, then we could take this whole block and copy on again. The linked register is the address in memory of where we are supposed to jump back when we are done executing this second function. In Intel architecture, this is typically called return pointer, and it means the same. So what we do is that we start with putting the current instruction pointer on the stack, calling the link register. We continue downwards and continue executing. Where it gets interesting is that with this buffer overflow vulnerability, is that we on this local storage would have a small, in this case, too small buffer allocated, stack allocated buffer, which we can read into with no limits on how much data we can read into it. So let's say this buffer has 10 bytes allocated, but we are able to write 2,000 bytes into it. Then we would just override, you can see my mouse, we would just override up through all these registers and write whatever we wanted in them. So if we were to just override them with junk, then assume any embedded software developer would then say, but wouldn't there be some kind of watchdog mechanism in the CPU that would take care of this, that would say, oh, now the device has been dead for so long, now I'm going to power cycle it. I would say so too, but that's apparently not the case. This is a bit more explicit what I was trying to explain. If we imagine the C code here, we allocate a char buffer on the stack, and then we read in from console input into this buffer, and then we read 256 bytes, whereas there only were 10 allocated, and therefore we could just override up until we hit something we shouldn't. In this case, on this Moxa endport device, this is done through a TCP socket through its web server, actually. So basically, if you just send a web request to it that is too long, then it will die. It's that simple, actually. This buffer overflow vulnerability could potentially be used to arbitrary code execution, which again means that we could execute our own assembly code on this embedded device. To bring an example of that, which is not running on the Moxa, but is running on my PC, I'm going to bring in these series of online challenges that anyone can go download called ROP Emporium. ROP is the technique. It's called return-oriented programming. And this is the first of the tasks, which basically just says there's a buffer overflow, leverage it so you can call some specified function that we want you to. And then in this case, instead of dying and some industrial refrigeration plant would blow up, it will print out a flag on the screen that I then could go back and submit for points, like in the CTF that is running right now. So, this ROP Emporium challenge just gives us a binary executable file compiled with ARM 32-bit. I'm here using some Python code. It's on purpose that you can't really see all of it. Basically, I'm using the library called PwnTools to send some data to the to the binary executable, and then to take control over it. Yeah. I have a short demo of that. Everybody can see. This is the binary executable that I just mentioned, and this is the solve script. The interesting thing about this binary is that it contains a function called ret or return to win, and that is what the challenge description says, that you should take control over the execution flow, so you can call that function, and then you will get the flag printed out. So if I were to call this binary, and this binary is actually compiled with ARM32-bit, it's just that I have some magic installed on my computer, so it will automatically run in a virtualized environment. It will write some text message to us, some silly, goofy stuff that these challenges usually rely on, and we can write something to it, and it will say thank you, and it will exit. The solve script that I quickly showed in my PowerPoint is the same as I have here. Basically, we have a buffer here that we fill up with the character A that we can compare to the situation here, where we fill up the registers until we hit the saved linked register, which we then fill up with the address of the function called ret2win. So if I were to execute this solve script, it will again say silly goofy stuff, and we can then see how this A character is sent X amount of times, then the address of the function that we want to call, and then instead of just saying thank you, exit, it says well done, here's your flag. That is the basic principle of return-oriented programming, and this is a very basic example, but it's actually a really fun way to get into this kind of stuff. Okay. A fun thing to note is that the first time this kind of, they call it stack smashing instead of buffer overflow. The first time it was described in a white paper, a technical paper, was in '96. The paper is called Smashing the Stack for Fun and Profit. It's publicly available. The paper is 2 years older than I am, and still we see these kind of vulnerabilities, very simple vulnerabilities that anyone who is experienced in developing C code or C++ code should by now know how to handle. But here we are. Yes, talk is cheap. I have a video that would demonstrate the buffer overflow vulnerability, and I hope that the video on a video stream on a video will work. So basically, on the bottom right corner, we have the Moxa import device, and we have my colleague Jens' very, very tidy disk. On the top right, there's the Windows tool that Moxa provides to help configure and use these Moxa import devices. And on the left side, he is now going to demonstrate how the web interface works, and that he can go retrieve all data that might or might not be relevant right now. But yeah, again, the website still works. Now there's a proof of concept script he's running at it, which is still classified, unfortunately. he runs it at the target, and immediately you would see that the small light here dies. Very difficult to see, I think, up on the big screen. Okay. What we would then learn is that it should be down now. Yes, the web server wouldn't respond anymore, and it will not respond to a ping message anymore. That's all it took, running that simple Python script that I wish I could show you. Potential impact of this buffer overflow or denial of service vulnerabilities. In the IT world, those kind of denial of service vulnerabilities are not worth that much, simply because that you have high availability, or you have redundancy, or you have methods for easily patching your software or IT stuff. The thing is that in the industrial world, this means the world. It means a lot, because these plants, industrial plants, again, refrigeration plants, power grid, substations, anything, they are not necessarily high available on these kind of Moxa serial device servers. If you take one down, then you lose access to the plant. And what would happen then? Yeah. I can't talk for sure about every industrial plant, but a lot of those that I have seen, they have these kind of fail-safe mechanisms that simply does so that when they can't communicate with the controllers in the plant anymore, they, for safety reasons, simply have to shut it down. Because if they don't know what's going on, they don't know what kind of alarms and warnings and information is being sent back and forth, they'll shut it down. And so in that way, a simple too long web request for a Moxa device can shut down, potentially shut down a whole substation for a power grid, taking out electricity for very many people. The fun thing is that the last time I gave this talk and I said this exact sentence, the power actually went, and everybody was like, what is the Russians? And it wasn't. It was a breaker in the cupboard, but yeah, it was funny. Procedure of how we took apart this device. We started with some physical enumeration, we call it, of this device, which means take the lid off of it and look at it. We quickly learned that the processor, the CPU chip itself, microcontroller chip it is some kind of rebranded chip. Probably it is an ARM chip, we know that, but it is a rebranded chip, which means that we do not know what exact ARM chip it is, and therefore we can't just Google our way to the pinout, like which pin is what. Because if we were able to, then we could potentially be able to attach some debugging mechanism to this chip, and then it would be much easier to leverage this buffer overflow vulnerability into actual arbitrary code execution. We didn't get that far. Also, we were looking for control ports on the device, like if the device itself could print out some status messages or some log messages or something, but it didn't seem like there were any UART or RS-232 or something like that available. A thing worth mentioning is also that, of course, we went to Moxa's website and downloaded all the firmwares for it that we could get. And we noticed that the newer ones, they are all encrypted, but the older ones, they are not. So we started finding out where the where they started being encrypted, at what firmware version they stopped being unencrypted, start being encrypted. And rightly enough, my colleague Jens were at the last unencrypted version. That one contained a key for decrypting the encrypted versions. So yeah, if you just downloaded the newest encrypted version, then you wouldn't be able to unencrypt. But if you just did it in the right order, then you had the key, and then we could decrypt the newest versions also. We didn't find much exciting stuff in the firmware. Actually, they had used these mechanisms on the binary executables, like they have so-called stripped the binaries for any fancy symbols that we could leverage, and it just makes it hard to do some statistical analysis that would help us doing the arbitrary code execution. Then we went on to enumerating it on the network side, and it had a bunch of open services like SNMP. We could dump a whole lot of information that, yeah, there were information, but not really anything that we could attack it with. There were some other different services, like their own TCP thingy, where you can connect through the Windows tool, so you could tunnel the COM port, which is the basic principle of the MUX import. No, what we actually started with was the HTTP server, because it was just the easiest place to start. And my colleague Jens, as I've mentioned him a few times, he took care of that part. And it was really funny to watch, because he took his best IT hacking skill set and began attacking this web server from back and forth and everything, and quickly realized that it wasn't like a known web server that you could go and download from GitHub or buy or wherever. It was their own they had developed, but he couldn't really find anything interesting, and just he got more and more frustrated until at the last he just sent it a whole lot of A's to it, and then it died. Yeah. We were ready to report these vulnerabilities in March this year, and following that were long-winded and annoying and heavy discussions about when and where and CVSS score, and then ICS cert in USA said this is the CVSS score, and then Moxa said no, it's not, and then but we ended up finding a middle way of, I think it achieved 7.5, and a patch was released, and Moxa, they released an advisory, published an advisory. What do we do now? Maybe some of you are sitting there thinking, oh God, I have 84,000 Moxa imports in my network at home, not at home, at my workplace. What do I do? The thing is that Moxa has made a patch for this, but they have also made it so that you need to have a valid guarantee evidence for these Moxa devices, and then you have to, by yourself, go to the technical support and ask for this patch. And I'm pretty sure that the reason they did it that way were that they were getting pretty tired of me and Jens just taking their stuff apart. So if any one of you do have this evidence of guarantee and are willing to go get the patch, then my email will be on the last slide. Another thing that could be done is that we have PCAP files where we have captured the malicious traffic. Those could be used to instrument advanced firewalls, EDS systems, to drop these malicious packets before reaching the import device. And finally, the HTTP service can be disabled altogether. It can be using the Windows tool that Moxa provides, where you can also do the basic configuring. Also, more spicy stuff for Dr. B, as promised. Recently, we found a vulnerability where we, on a whole series of Moxa, I think they're called Universal Communicator, we could simply bypass the root authentication altogether when we are physically connected to the device. That is an interesting one, because how do you rate that? Because it is only available when you are physically connected to the device and not over remote. And that was also a topic for long-winded discussions with Moxa, if that is a problem or not. And I can kind of see the point that if you can't leverage from remote, then what can you use it for? But I still don't think it is a good idea that you can go to this, which is basically just a small Linux computer, and then you can do it just and then you can log in as root. That is all that I had to say.
Perfect, thank you. All right, well, let's have a chat.
Let's have a chat.
Let's have a chat. So, why on earth did you look at this device? Was that the one that you just picked up from the box, or just the Moxa device, or someone just told you, hey, look at this device, there might be something vulnerable in there?
You know the answer to that, don't you?
I do, but please tell me.
The thing is that my boss, Mikael, and Bernard, they know each other, and therefore Bernard also knows that Mikael has this thing for these Moxa devices, and it was him that basically took a bunch of them and threw in the back of me.
So yeah, something just lying around, right?
Yeah, something just lying around. But no, it is a really interesting device, and as I said earlier, the whole leveraged in the Russia-Ukrainian war and other types of attacks, it is used everywhere. We have multiple customers who use them, and they're used everywhere, and it was actually really interesting.
Right. Now, no matter how we might downplay the denial of service attack here, in ICS networks, denial of service is quite important, because everything is there, not primarily, well, it's more availability that matters here. Now, in your talk, you tried to mention also the remote code execution as well. Now, how would you approach now the Moxa device? Because I know that the industrial control systems are not famous for having, I don't know, good security measures in place like memory protection, randomization. Specifically, if you're looking at the hardware and doing hardware debugging, that is really a very huge pain to connect and see what now happens in the memory of the device. Is there anything that you've tried to figure out? And if not, what would you think, what would be the next steps that you might pursue, regardless if you're going to do this or not?
Well, the next steps would be to do some extra investigation in what is it actually, the chip, the MCU that are in the device, what is it actually, which model is it actually? And from there you could find out the pinout, which pin goes where, and from that you could figure out where to attach your debugger. That is the first step. When you have your debugger attached, you also need to know where to stop the debugger, where to break the debugger, and everything. And maybe, depending on how the debugging pins are configured or not configured, you can dump the whole memory from the MCU via the debugging line, the JTAG perhaps. Or you would need to statically analyze the kind of encrypted firmware that you download from Moxa's website.
Right, so also getting the firmware itself and analyzing the firmware would be part of the process.
It would be
either
crucial,
either
yeah.
reading the firmware off from the chip or downloading the latest firmware update or whatever there is. how easy would it be to read the firmware and actually analyze it afterwards? Not always you would understand what the developers have intended there, but you have a developer background and you have engineering background as well. Would you say that reading the firmware and reverse engineering, or at least figuring out the key aspects, would be relatively straightforward, or that will take a lot of time to process?
I don't think straightforward is the right word or expression. But depending on how, well, typically that kind of ARM chip would have a so-called JTAG interface, which is a bunch of pins on where you can attach this debugging mechanism where you can step and stop and break in the code and see what's going on. Through that interface, you would also be able to read what is currently lying in the flash or the memory of the MCU. By MCU, I mean microcontroller unit. And that you would need to analyze from top to bottom. And yes, that would not necessarily be the easiest or most fun thing in the world.
Absolutely. Unless someone is experiencing sleepless nights and just tries to find some cure for sleep, and then just reading the code might be the one. Now, please do tell us, if you can, about your experience with working with a vendor, and if you engaged any other party there while doing the vulnerability disclosure process. As much as you can, please. Just how did you feel in this process?
Okay. As I tried to say earlier, it was a really, at least compared to IT, where you sometimes have a patch ready in a few hours for a critical vulnerability, then 4 months is a really long time. And me and Jens, we were getting really tired of it. But the other day, when I was preparing this presentation, I actually found a hint to why they didn't really like us that much. And that is in is my screen still shared? In the video that we sent Moxa along the proof of concept, there's this line: Nport should be slowly corrupting its own memory. Now we need to give it 30 seconds to fuck itself up a bit. I'm just not sure that Moxa appreciated that.
Yeah, you tried to be very direct and very blunt there. In the meantime, are there any questions from the audience? There is one question, please. Let's take it from the audience as well.
Thank you for your great presentation. It was very interesting. I know many have slept, but I think from my perspective, it was very interesting, and I know that it's a heavy job under there. My question, have you found any ways to harden device? Because in cases where you cannot patch them, you try to harden, and that's how you mitigate the problem.
Well, in the ICS world, the vendor's answer to that question is always the same. Put a firewall in front of it. And yeah, then the best bet I have right now is to either get the okay, my screen is not that, doesn't matter. Either get the patch from Moxa or disable the HTTP service. That would be my way of hardening it. Does that answer the? Yeah.
Right. I guess one of the key recommendations specifically in the OT networks is disable the services that you do not use, or enable them only once you require them. I would guess like there would be no need for constant configuration of that device. You configure it pretty much once, deploy it in the network, and you can safely disable the web interface. Would that be applicable here as well?
Well, I can't see a reason why not, but maybe somebody has a better perspective out there.
Right. And one of the things that you're also doing is the ICS range. Now, for trainings, how well can you deploy the hardware and scalable hardware for the training to be given to the students within the ICS and OT world?
Okay, so the idea behind the ICS range is that you get remote access to a bunch of ICS-related equipment, which you and then you get presented with some material along with some challenges, very CTF style, and then you get to hack the equipment, retrieve the flags, submit the flags for points, and then you can compete with your colleagues that way. The challenge is then that if you have, let's just say, 48,000 people trying to hack the same Moxa device at the same time to retrieve a flag to submit on the page, then something wouldn't work. Somebody would need to, we need to hire somebody to sit in the data center to sit and power cycle the device every time somebody killed it, and I'm not sure that would be a good way to handle it. What we have done instead with this kind of problems is that we have written some C code to virtualize a problem or vulnerability very much like the one actually described in the CVE or whatever we refer to, and then simply letting the student hack the virtualized environment instead of the actual physical one.
Right.
Combined with the actual physical equipment for where that makes sense.
All right. So final question from my side, as long as there's no questions here, raised hands, is what is the next device that you're going to pick out from the box?
Who says we're done with this one?
Okay, perfect answer. With this, I thank Kasper for the talk, and a round of applause. Thank you. Thank you so much.
Thank you.
It is always good to hear applause here on site when we were fully virtual. This was that was a luxury. We didn't hear this at all. Now, stay tuned, because in about 13 minutes, we'll be back here on stage, and we'll be joined in by our Canadian counterparts who will explain how to do mainstream reverse engineering and analysis of malware. So see you soon. Welcome back. I hope you've enjoyed your day so far. And now the last speaker for today. We have two young gentlemen joining us from Canada remotely. That is Jean-Pierre and Kevin. And they're going to talk about the solution that might help us, and actually is helping us, on analyzing and understanding the malware. All right, gentlemen, welcome to the studio, welcome to the CertLV, and the cyberspace is yours.
Maybe I should say good morning or good afternoon, I guess, for you guys. We're live from Canada here. So I'm JP Vigneault. I'm the team lead for the malware analysis automation team in the Canadian Cyber Center. And with me, I have Kevin Hardy Cooper, who is also working on the assembly line team. So today we're going to walk you through what is assembly line, but we're going to do so in basically looking at some malware samples and try to highlight some of the features that assembly line has, and you might also get some ideas of how we use assembly line here in Kenzen Cyber Center. So to start, let's introduce the Kenzen Center for the Cybersecurity. We are the Canadian National CERT. We're also part of the Communication Security Establishment. So our role in the CCCS, that we call, is to inform and protect Canadian, but also to develop tools and technologies and help defend networks in Canada. So today we're going to talk about what is assembly line. So assembly line is a scalable file analysis system. So it's a system that is main purpose is to do triage on files. So to get the files that you have in your network, either entering through emails or web gateways and other places where there's files coming in, and send them to the system where they're going to be analyzed and scanned. The system scale, and we're going to talk about that a bit, but it can go over like multiple million of files coming in a day. Its main purpose is to automate the analysis for incident detection, but also to help incident response team, forensic team, so anyone that have files or malware. One key thing with assembly line is it's easily integrated into existing ecosystem. It is a open source system. So it's been, the version 3 of assembly line has been open source in 2017. And we've open sourced the latest version, which is version 4 in 2020. So having the system open source allows us to allow people to integrate it within their own ecosystem and to tweak it to their own need. So let's talk about open source a little bit before we dive into the tool. So the CCS believe that cybersecurity is a team sport. So we believe that community's tool and standard help us work together. So attacker works together. Defender needs to also work together. And sharing tools and signature format and standard is one way that we can work together. So that is one of the reasons why assembly line is open source. But we go beyond just making the tool open source. We also contribute heavily to many projects. So the ones that are below are just a few of the ones that we are contributing to. We're really trying to improve the tools based on our operational knowledge of using them. And assembly line helps you integrate, scale, and maintain the community best tool with our operational knowledge. So we take care of making sure that open source project that we integrate into assembly line are like kept up to date and are doing at their best. So what is assembly line? So in terms of the system, it is a Kubernetes stack. So it runs on top of Kubernetes or MicroKDS. There is also a Docker Compose deployment for smaller appliance. It's built on top of open source technology like Elastic, Redis, Unicorn. So we use Elastic and Redis for queuing files and also for storing the results and making everything searchable in the system so you can pivot on things. And then there is many different analyzers. In assembly line, we call them services. And what you're seeing scrolling there is just a list of some of the services. All of them are on GitHub. We won't be able to go over every single service today, but we will highlight some of them for the malware samples we're going to be looking at. But there's a very wide variety of technology available as part of the assembly ecosystem. So assembly line is designed to handle all of your file, all of the file coming into your environment. So that can be, if you can see on the left there, it can be places like emails, attachment coming into your environment. It can be file download through gateways. It can be file from your EDR platform, or it can be to support analysts, incident response, or forensic teams. So the idea is that assembly line will centralize file triage, scanning, but also enables you to integrate commercial platform into it, such as antivirus, sandbox, and other security product. So you can integrate those with assembly line. And you can also import all of your rule sets into the tool. So either open source or commercial Yara signatures, Suricata, and also Sigma signature. So with all this, when files come into the system, assembly line is going to support a wide range of file types. It's going to have different analyzers for different file types. So depending on the file type, different analyzers are going to be used to scan your file. One of the key goal of the tool is also to deobfuscate and extract IOC. And you're going to see a bit later why it's important. But the goal with assembly line is not just to say a file is malicious. It's more than that. It's also to extract useful in case of compromise so you can build some automation later. So files are scored, and there's heuristics and tags. We're going to go over those. And the analysis is done recursively. And the output from the systems are alerts, indicators of compromise, and also powerful REST API that you can build and automate things like any ideas that you might have for your entire file collections. So let's take an example that I'm sure it has happened to nobody here. So once upon a time, on a Friday at 4:30, as you're planning to leave for a long weekend, there's a new alert. And you happen to be the one that's in charge that day, or the one left in the office. So let's look into an alert, what it looks like in the assembly line, and let's take it from there. So this is the alert perspective of assembly line. This is just the list of alerts. Here, there's a single alerts. So what you're going to see here is the number of times that this file has entered your network. So if you're sending all of the files you have and you do the collection, like I mentioned previously, you're going to know many times or many users or many machines have seen this file. It has a file type. It has the labels that analysts would have applied on the alert. And it has a few detection like counts to give you a rough idea. Also has the assembly line verdict. So if you click on the alert, you're going to get more information. You're going to see there is alert information, so ID, times, things like that. You're also going to see metadata. So along with the ingestion of your file, you can include like metadata that suits your needs. In this case, we have just like SMTP, and it's going from totally legit email and it's going to a Mr. Click-a-lot. So yeah. You also have the IOC to act upon. So there's that. So there's a URL there that was extracted, and heuristics that were flagged. So you can see files infected. That means there's some antivirus hits on this. There's some batch files, there's network IOCs, there's archive involved, and yeah, a few things. So clearly, this looks like something bad going to a user. Assembly line also enables you to do automation on alerts. So there's something called workflow action. And what this allows you to do is to build queries like this one, and build queries that will apply labels. So the idea is that you can build different queries for different, like it could be a phishing campaign, could be like other things like that. And you can apply whether it's a malicious, false positive, the priority, and also labels. The labels can be user defined. So in this case, we're applying the phishing label. And assembly line will then automatically execute this query on any new alerts coming in. So the labeling is going to be automated from that point on. So before we go further, let's introduce some key concepts. So assembly line, one of the first view you're going to get when you look into a file is the submission report. The submission report is kind of the TLDR of the analysis. So it includes a summary of the entire analysis tree. It includes the system verdict. It includes the error rule, like we have a few error rules here that are triggered, highlights, indicators of compromise, which is what we're seeing right now. And the report is fully printable. And you also see the attribution if there's a error rule that was able to attribute this sample. So in this case, we're looking at Crock-Pot sample, it looks like. Another thing that's important is the heuristics. So the heuristics, basically their goal is to help to score a file. So the heuristics are responsible for scoring, but they're also responsible for highlighting malicious element of a file. So in this case, what we're seeing right now, what I open are like three different heuristics. It's going to replay right now. So you have the full submission score. In this case, we have like close to 6,000. And then what you're seeing there is all of the heuristics. So like some AV, it's like we have a single link file into an archive. That's kind of strange. A weird command line. The heuristics, like I said, also have like a maliciousness level. So that's based on the score, and that's how they are colored. And they are also fully searchable. So you're able to build queries to find new things, basically, that we might have missed. So if we go a bit further into heuristics, so each of the heuristics have an ID, which can be queried on. They also have a name, and they have a description. Some details. So, okay, so in this case, this was the file that was a single file that was in the archive. And they are color-coded based on the score that was given to the heuristic. So another key concept beyond heuristics are tags. So all of the bubble type of labels that you're seeing there on the screen, they are all tags. The tags can be clicked on to highlight where they are present in the file tree. So that's what you're seeing in blue at the bottom. Depending on which tag I click on, that it tells me which file is present inside. And you can also search on tags. So if you have, in this case, I have a static URI, and I can find any other files in the system that have the same URI inside of them. So it might help you to pivot on newer files that would not have been detected, or maybe they were not detected at the time that they came in the system. But that is not just true with URLs, it's true with any tags, and they can be combined together in Lucene search query. So kind of Boolean, mostly Boolean search syntax. So and this, or, and then wildcards and other things like that. Yeah. So if we look inside the actual analysis that was done here to generate the alert that we saw at the beginning. So I mentioned that assemblying does its analysis recursively. So what that means is when a file is submitted, in this case, what was submitted to the system is the top one. So if we see here, it was a HTML file. The HTML file is going to be dispatched to like any services that can analyze HTML file, or any services that will analyze any file, like Yabra or Antivirus. And as those services are doing their analysis, they might extract other elements from a file. So in this case, something that makes a lot of sense, like from a HTML page, we extracted some JavaScript code. And then it kind of goes sideways. So we go down to a zip and then a shortcut and batch. And so that is interesting. Yeah, exactly. So if we jump into the file detail, we will see, I'm looking at the HTML file here. So the HTML file, we know the type, we know the number of times we've seen it, the first time we've seen it, and we can also see the content of the file. So in this case, this is the JavaScript that was found. So we can look like some obfuscated JavaScripts. And interestingly, there is also a password. So more on that a little bit later. So the file view will allow you to look at the hash, the types, number of times you've seen it. It also has the ability to let you download specific file that were extracted. One thing that is nice for corporate environment is that any file that you download from the system will be inserted in the cart format. So what that means is people can safely, like your analysts can safely use the system. And if you need to go and take the file and take it to a reverse engineering environment, let's say, you're able to download it. It will be safe. There's no chance you actually run the file on your computer. It will not trigger antivirus and other tool security product. And then you can take that file, move it into your offline reverse engineering environment. And then there is a Python package called cart that you can pip install, and you can just uncart the file, and it's going to give you back the original file, which you can start to do your analysis on. So if we look into the second file that was extracted, we add some JavaScript. So JavaScript is analyzed by a service called JSJAW. And what it does is it tries to do emulation on JavaScript. So as you can see here, it's not really readable. So it's like it would take some time for a reverse engineer or someone like a malware analyst to look into this and to like figure out what's happening. Luckily, JSJAW was able to basically extract a zip file. So it emulated the JavaScript and found that there was embedded in there a zip file. That's what you're seeing at the very bottom. So any files that are extracted are going to be put at the bottom there, and they're going to be resubmitted into the system where, depending on the file types, there might be a completely different analysis that will be done on them. So yeah, so JSJAW gave us a zip file, which is pretty cool. So a zip file will be handled by the extract service. So the extract service, its only goal is to take archive or like ISO files, like some HTML and basically any kind of archive format, we try to support them in our extract service. So what the extract service will do is pretty simple. It's to extract the content of the archive, and we've seen some pretty interesting thing recently with ISO-file. Like people have started to use weird format of ISO files, well, like DF files, and bootable ISO file, which cause all sorts of problems. But they are now well handled in assembly line. That's fairly recent. So if we look into the extract analysis here, what we can see is, yeah, one thing that is pretty interesting is that extract actually use the password that I shown you in the HTML file at the beginning. But if you remember, there was HTML and then JavaScript and a zip file. So one trick that assembly has up its sleeve, and this is getting more and more common, where the like password are not just in the email, but they're actually in attachment themselves, is that assembly will be able to compute word lists, which are then going to be used to brute force password down the line. So it pass down these words to subsequent services in a side buffer. So in this case, we were able to use the password from the HTML and extract a link file. We also flagged that this was suspicious because there was just a link file I think this was it was just a link file in a zip file. So link file or Windows shortcut are analyzed by our characterize service, which mostly run EXIF tool and a few other tools like link parse that we're seeing bottom there. So characterize is a service that generate information about like documents. It will generate entropy and any metadata that's embedded. So that could be a Word document, but in this case, this is a link file. So what we see here is the link file as a command here, which has a bit of obfuscation. Not that much, but just a bit. Because remember, this was in a zip file which was password protected, so there's not big need to obfuscate this. So we can see that the person actually wants to mimic as MS Edge, so that's what the end user would see. So it borrows the message icon, and we can also see that there's a suspicious command line. So this is a heuristic that the characterize service has raised and flagged this command line. So the next service in line to analyze the extracted Windows command is batch deobfuscator. So batch deobfuscator will actually deobfuscate batch files that are pretty obfuscated, but also analyze the content of some type of commands that are of interest. So in this case, it found that there was a curl command in the command, and it brought the destination where the content will be saved, also the URL, which is kind of what we were after. So not only we were able to like find the URLs, but we were able to find it in a context that is suspicious. And that's why the system was able to highlight this URL as being well, you're seeing orange. So that's a suspicious. That's because there is a heuristic along with the URL that is that this heuristic is has a certain score to make this URL suspicious. So yeah. Another nice thing is we have a new service which is called URL Downloader. And what URL Downloader is, it will, if you want to, that's something that needs to be enabled when you submit the file. URL Downloader will attempt to go fetch anything that is hosted at URLs that have been flagged by other services that are suspicious or above. So in this case, because this is a suspicious URL, URL Downloader would try to fetch this payload. In this case, it couldn't get it, so it didn't continue the analysis. But if we were able to actually fetch something, we would actually continue the analysis and go deeper into it. So we've looked into the alert. We've looked at there's something that's about to ruin someone's weekend, maybe. We've looked into all the analysis was done. But one really key thing to assembly line is its powerful REST API. So assembly line has a REST API. I've shown you mostly the UI so far. Everything that is done in the UI goes through the REST API, so it can all be done via the REST API. It has a vast set of function to send, like ingest data into the system, so submit data. Like searches, pull files, basically do any kind of automation that you might want to do with files coming into your network. So this is just one example. If you remember, we have an alert. This is a little bit of Python code that just looks into the analysis that the analysis that was done, the submission that we just went over. And what this code does is very simple. It just parses the data that's stored within Elastic, and it extracts the URLs that were found. And the idea there is that if you have ingestion in place into your system, if you have a workflow where analysts are labeling certain things that you might want to trigger certain action on, then you're able to build some automation and potentially save someone's weekend by blocking domains or taking other action on your network. And all this automatically. So you've got a chance to click and block something before somebody actually clicks on a malicious file like the one we just went over. Without the deep analysis that assembly line does, however, we would not have got this URL because if you remember, it was within a zip file that was password protected. So other security product that I know would have flagged this file as being malicious, but might not have give you the IOC that you need to action. So a few other highlights that assembly line has. So I went over a analysis, but assembly line is a full-fledged platform to basically centralize all of your file analysis. So it will allow you to import your signatures. Signatures are pulled from Git repository. You can use your own private Git repository or use some open source one. It supports many kinds of different signatures that will be applied at different times. So, for example, Cicada signatures are network signatures, and those can be quite handy for sandbox PCAP analysis. Or if a user submit a PCAP, it might be an easy way for them to get the Cicada hits on a specific file. Same goes for Sigma. So Sigma are quite useful for analyzing Windows event logs and other type of logs. So whether Windows event logs are collected by your sandbox, or if a user submit Windows event logs that might have been collected from a forensic case, let's say, and submitted to assembly line, it's going to be able to apply Sigma rule on that. And also config extractors. Assembly line will build metrics around all of the signature, but also the heuristics. And you can monitor how they're doing over time. If some are starting to cross some false positive and creating too many alerts or things like that, it has all of that built in. Another key thing that I couldn't show during the demo is it has a built-in safe list. So what that means is if you have sources of known good hashes, for let's say, like NSRL, you're able to import that in the system. And assembly line will skip the analysis on those files. You can also mark some IOC or tag, like the tags I was talking about, as being safe. So the example I took was fairly clean, but there are cases where there is a lot of, just like if you take an XML file, for example, there's going to be a lot of RFC URLs and other URLs embedded that are not malicious. They're just standard part of the XML format. So SMLine gives you the ability to safe list those, and you can do that through regex as well. And what that's going to do is it's going to show them as green, like what you're seeing in the bottom. But you can also hide them completely. So it's give you basically a tool to clean up the report, and also potentially avoid trying to block, like I was saying, some domains that are not malicious. Another nice service that is part of SMLine is the malware config extractor. So SMLine config extractor, it doesn't do the memory dump itself. So it needs either like a sandbox to do the memory dump, or other tools, or if you can submit a memory dump directly to the system if you want to. But we took an approach where we try to integrate the community's best format. So the service will accept extractors written for CAPE, MWCP, and also our own format, which is called Mako. You can have a look on the Cyber Center's GitHub page for Mako. One of the key elements for Mako is it standardized the output of the extractor, which is really important when you want to build automation. If every extractor is using a different terminology, it makes it really hard to know, oh, this is a C2 and this is like something different. So Mako has a strict ontology, which means that we're able to tag and label things very well. But it supports all three. So yeah, without further ado, I'm going to introduce Kevin Ardy, who's going to talk to us about macros.
Thanks, JP. Hey everyone, my name is Kevin. Thank you, JP. As you can see, SMLine is pretty awesome. And in the news recently, Microsoft released that macros are no longer enabled by default, which is great for the cybersecurity community, possibly not good for threat actors. So they have to adapt. And so the next big question is, what are they doing next since macros are now disabled? Well, we've noticed in SMLine that these threat actors are using archives, specifically non-zip archives, such as ISO files, VHDs, VMDKs, some subsets of ISO files called UDFs. And we're seeing a lot of these files in SMLine being submitted for analysis. So as you can see on the screen, there's a query that is in SMLine that I made, and you can just look for all these different archive files and the ones that meet the classification of TLP white. And here are the results. There's 365, that's one for every day of the year, but we've seen these in the last 2 months at least. So I suspect there's gonna be a lot more in the future. So we're just gonna cherry pick one and deep dive into it for the presentation. So here's one, it's an ISO file. It's the 1FC7B hash that you see there. And this is a brute Ratel C4 malware. And it uses DLL sideloading within an ISO file. So we're going to talk about DLL sideloading a little bit later. But right now, this is the structure of the ISO file. You got, the main ISO file, and then these are the indented files are the ones that are found within this file that we were able to extract. So we have a link file. We have this unknown file called OneDrive update, possibly encrypted. That's why we're not able to find out what type it is. You have this version DLL. You have a version DLL. And you have a OneDrive updater exe file. So just right off the bat, by looking at the files that are within this ISO, and there's an exe and there's a DLL, this possibly could be DLL side loading, which we're going to talk about later. So let's start with the link file. So when we analyze the link file in assembly line, we see that there's a suspicious command line argument. This is done in the characterize service, and it looks like the link file opens command exe. We're able to extract the batch file from this link file and using the batch deobfuscator service that JP was talking about earlier. And this batch file contains just a quick little command called start and OneDrive updater exe. So OneDrive updater exe is the file within this ISO. And it seems like the link file just tries to run this file. So something interesting of these files within this ISO being used for this malware are that there are some legitimate files and some illegitimate files. So the first three, the ones marked malicious that assembly line was able to identify as malicious files, those are illegitimate files. So those are used for the malware detonation. And then these two here marked as I for informational and not M for malicious. These are actually legitimate files that we were able to find in our safe list and are actually files used for Microsoft signed products. So just a high-level overview of what DLL sideloading is and how it's integrated into CAPE. CAPE is a dynamic analysis environment that's open source, so you can find it on GitHub. It's a sandboxing tool. It focuses on config extraction and payload extraction. It's a fork of the Cuckoo sandbox, which was a very popular open source tool, which is now no longer maintained. CAPE is actively maintained, so CAPE has a lot more features than Cuckoo did. We use CAPE in assembly line in order to analyze files dynamically, and CAPE does have support for DLL sideloading. Prior to us seeing all this influx of archive files, however, CAPE only supported zip files as the archive file to be analyzed for DLL sideloading, which doesn't apply to these archive files that we're seeing that aren't zip files. So there's an area of improvement there. All right, so this is the general process of how the files within this ISO file that we saw and how they interact with each other. So we have the link file. It's running this command where it starts the OneDrive updater exe. Note that this is a relative path, not an absolute path. So the link file needs the OneDrive updater exe to be in the same extraction folder as the link file in order to actually work. So the link file runs, it starts the exe, and the exe is legitimate. And so here is where the DLL sideloading happens. So the exe normally would load its DLLs from the System32 root folder, but the exe is also lazy. So it looks in the folder where it was extracted to. And if there's a DLL that matches the same name as the one it's looking for, it will use that one instead. So that is where this malicious version DLL file is being used. And so the exe loads the DLL loads its malicious function and then runs that, which then looks for the OneDrive update encrypted file, which is in the same folder. So it'll decrypt that. It'll then use that information in order to inject a process and beacon out for the next stage of the payload. So DLL sideloading is a great anti-analysis technique, because if you're using a security tool that extracts files from an archive, such as like zips, ISOs, UDFs, VHDs, etc. And so you're using those extracted files, and then you're analyzing each file in isolation relative to the other extracted files. That's not going to work with these samples, because these files are heavily dependent on each other being in the same extraction folder or being in the same environment. So this was an issue with assembly line before, when we were seeing these files come in initially, because we would extract the file, we would receive the archive file, we would extract the files within the archive, and then we would submit each one to dynamic analysis or our CAPE sandbox, but they would be in isolation. So the link file will get sent to CAPE. The link file we know uses that command, but that looks for the exe, and that exe doesn't exist in the CAPE environment, so this link analysis result would not give us what we want. Then we would extract the legitimate exe to CAPE, and this is legitimate, so it doesn't do anything interesting. And then we are looking for and then we submit the version DLL, so that's the other legitimate file in the ISO file. And we've sent that to CAPE. That does nothing interesting because it's legit. And so this doesn't give us what we want. And then we then submit the version DLL, which is the illegitimate DLL file. And so this file only executes its malicious function when it's being loaded into an exe, and CAPE doesn't do that when it's running DLL files. So this won't give us what we want either. We don't submit the encrypted file, the OneDrive.update file, to CAPE because we're unable to identify it correctly, so we don't know what application to actually run it with. All right, so that was the issue before, and this is how we addressed it. So CAPE did have the option for submitting a zip to, or submitting a zip and analyzing a zip, extracting into a folder, and then executing the first interesting file that it found within that folder. But there's an issue, there's a bunch of issues there. So the first issue is that it only supports zip files, and now we're seeing non-zip files. The second issue is it would only run the first interesting file. So if you had more than one interesting file in the extracted folder of the zip file, say for this sample, we have one exe and two DLLs. If CAPE just found the first, say the legitimate DLL, and then that was the first one that we would find that would be deemed interesting, it would run that, and then nothing would happen, and the analysis is over. So we wanted to run all the interesting files in the archive, so then we'd be able to get all the different possibilities, and we'd be able to hopefully eventually find the path in order to execute the malware correctly. So something that we built out is generic archive support. So this is a package that you can use in CAPE, and it supports all these different, basically any archive that can be extracted with 7-zip. And we also run all the interesting files within the extracted folder of the ISO file or the UDF or the VHD. And then we're able to all within one submission. So it's no longer run in isolation and everything is going according to plan. So this would look like this inside the CAPE analysis environment. So say the DLL is the first in the folder extracted, we would run that. This is perfectly legitimate, so this would do nothing. Then the malicious DLL would run. This requires to be loaded into the exe in order to actually do the malicious stuff. So that wouldn't give us what we want. Then we would try to run the exe, which now is able to access all of the DLLs that it needs. And the link file also points at the exe. So these both are execution paths that would both load the DLL, the malicious DLL using DLL side loading, and then this would decrypt the encrypted file, which would then beacon out. And there's that beacon that we're able to see. So awesome. So this is good, and that's good, and this archive support is good. And believe it or not, this is actually available in a CAPE sandbox near you. So this has been released to open source. It's available right now. If you don't use assembly line plus CAPE, you can just use CAPE, and you're able to actually get this functionality in whatever dynamic analysis environment you use. And yeah, so that's wrapping up that presentation. We're from the assembly line team, JP and I. If you look here, this is the email address for the official way to contact us for any queries that you have. The link below is the link to our documentation. And if you have an informal question regarding like technical problems that you have, we have a Discord chat, and the link to our Discord is at the bottom of the documentation main page. So thanks for listening. If you have any questions, let us know.
All right. Thank you for the presentation. For sure, let's start with the, there will be one question from the audience, so if you can get the microphone here to the first row, please. But I'll start the questions from my side. So you've invested a lot of time, your team, to develop the tool. However, this is just a software. Can you tell us about the hardware requirements that might be there for me to start using it? If I say, okay, I want to deploy this now, what would be the bare minimum hardware requirements that you would say, hey, this is what you would require?
Yeah, so can you hear me? Just,
yep.
Yeah, good. Excellent. So the minimum hardware requirement is a single server would do just fine. It needs a lot of memory because of Elastic, and we need to launch many Docker containers. But you can do that on, I don't know, maybe a 64 gig, like hopefully maybe some Xeon CPU, like a decent server would be ideal for low volume, or also to support a SOC team. If you want to use this though as the center of all of your finances for an enterprise, you're going to need something larger. So what this means is probably a community deployment. That being said, SMLine has been developed in the cloud. So if you do have access to a cloud tenancy, that is a very viable option. We've tested it on multiple cloud provider, and we operate some deployment on there as well. So yeah, don't know if that answered the question. We have more detail on our documentation page as to like minimum spec, but expect a need for a good amount of memory and a decent CPU for a single node.
All right. Yes, you gave the explanation for sure. So you're using multiple tools, right, to automate, and this is where the assembly line comes into the term or the name that you gave. So assembly line will go and iterate over the tools, if I understood right. Is there a particular sequence how you would run those tools, or you would just submit the sample at the same time and do the parallel analysis, or you will wait until one tool produces the results and then feed those results into another tool? How does this work from the behind the scenes?
Yeah, so the way this works is services, we didn't go into that level of detail, but services have a stage at which they run at. So if you set up an SMLine system and you look into the services, you're going to see settings where it's the stage. There's other options as well, whether you want to give that service internet access and things like that. But what the stage will do is it will determine in which order it's going to get the file in. So we have some filtering service, for example, the safe list is going to run first. And it's going to look if a file is safe listed, and then it's going to stop basically the processing of that file if it is. But we have other stages like the main stage, and then secondary stage, and then the final stage. And if you run at a later stage, you have the ability to look into the results that were produced by the previous services before you. Just to give an example, the URL downloader service that I mentioned, where if there was a URL that was found and it would go try and fetch it, that service run at a later stage, so it's allowed to see the URLs that might have been extracted before it.
All right, thank you. I mean, you gave a very, very good, precise explanation and answered my question for sure. Now, not always what we need to analyze is going to be the malware, right? It might be a benign file, but we don't know at this stage if that is malicious or non-malicious. Because the adversary might be just abusing and living off the land, abusing the actual just software that is residing on your system. And if I throw this file into the assembly line, it will at least give me the behavioral analysis that I can, as an expert, afterwards analyze and figure out if that is something that can be abused or not. Is there anything that can more help me to identify the use and functionality, even of the benign files from the assembly line? Not just saying, hey, this is malicious, but hey, this might be abused by a malicious threat actor.
So there's been attempt in the past to scan, for example, Docker container and other type of files that include a lot of other files embedded inside of it. Assembly line is really geared towards analyzing, finding the needle in the haystack. For binaries, we're going to rely a lot on Yarrow rules. Sometimes the behavioral is gonna work as well, in terms of running the file in the sandbox. One thing that I didn't say and probably worth mentioning is that we don't run every file in a sandbox. SMLine doesn't do that because it's very costly to do so. you have actually ways of configuring what you will send in your sandbox based on what the static analysis was, the result from the static analysis. Assemblyline though will find URLs and other elements, but for a legitimate file, it's most likely going to come back with no heuristics, some information, some things that might be embedded. Score. There are some heuristics that are to trigger the sandbox, for example, analysis, where it's weaker in skaters, like using PE, header information, and other things like that. But to identify legitimate file, that's we don't focus on that.
All right, we'll take the last question from the audience. So there you go.
Hey JP, it's Captain Sharman here from Canada. Nice to see you again. Just had a question. Obviously, Assemblyline is an analysis tool for files and et cetera, and you really use a sandbox. But obviously we used your version, CCCS's instance of Assemblyline. But even this applies to anyone who just has to build their own. Over time, you're going to have multiple IOCs that you're going to flag as malicious over time, right? Is there a way, a really good way, to do bulk kind of IOC lookups on Assemblyline? You can use the API and use the search feature, but that would, you have to do individual ones, and if you have a long list, you may not want to do that. Is there a way to do like a kind of a bulk lookup?
So yeah, our solution to that is to use the REST API. I assume you're talking more of a UI way of doing that. So if you had a list that was maybe commiserated, if you could just like put it in and see what comes back.
Exactly, yeah. Like any way to do anything other than individual lookups, which kind of bog down the server as well, right?
Yeah, no, we currently don't have a way to do that. We're looking at a way to submit multiple files together, but it's not what you're asking for. Really, what we would do in that case is build a very, very simple script that just do the search and iterate over your list of items.
All right. Right. So it seems like there's a feature request from your fellow Canadian members as well. JP and Kevin, thank you for joining us today. I know it's early morning. Well, it's morning on your side. It's already afternoon here. So I do appreciate you being awake that early in the morning and coming here and joining us here in the studio. With this, thank you and applause from the audience. Thank you. All right, with this, we will immediately carry on into the next section of today. I mean, this is a final. In the schedule, you will see that's written like final keynotes, and actually what we want to talk about is the CTF, Capture the Flag. So the Capture the Flag is an event that started today, early morning at 9 o'clock. It will run for 2 days. It will end tomorrow at 1600 here, local time, Riga time, and it will run overnight. So all of the participants will have the chance to battle and carry on finding the solutions to all the nasty and challenging tasks that our CTF developers have placed there. Now, altogether, we had accepted a limited number of teams, which are 40 teams with a requirement to fulfill 5 experts on the team. However, not all teams that we accepted had the 5 experts. Now, nevertheless, we had majority of the teams that filled in the 5 people requirement, then followed by 4 people on the team, and then afterwards being accepted with 2 and even 1. Now, altogether, across 40 teams, we have 390 players that are engaged in solving the challenges. Now, a little bit about the challenges. There are 3 categories, and everything is about bringing it to the smart level. We have the smart home, we have the smart city, and we have the smart airport category. Each of the categories contains 10 tasks that have to be solved, and the flags have to be identified and submitted to the system to get the score. Now, the teams will get the score based on how fast you are to respond. The first team will just get the majority of the points, and when the follow-ups will get a little bit less. You are encouraged to use the hints, and there are hints available. Do not bang your head against the keyboard and don't go for the Operation Broken Keyboard. Just look into the hints and see if they can be to any advantage for you as well to solve the tasks. Now, for the overall changing picture in the battlefield today, there were at least, and it's ongoing battle for sure, we'll see what happens tomorrow morning, but there are two teams that are fighting very, very fiercely, at least from the point perspective. Now that the first team didn't rise to the first place right away, it might be that they were still maybe chilling or having their morning tea or morning coffee, but then after they got the energy, they just started ramping up with the points. Now, the two teams are battling out, but four teams are on their toes and catching up right after them. After this, there's this main mass of the other teams. 11 teams are carrying on the battle, and they are not giving up, which is very, very good. There's one team that is actually stepping into the negative score. I think this is where you've taken already the advice on looking into the hints. Every hint that you look will deduce the amount, so you have to pay the points to get to the score. Or you have to pay points to get to the hint. And therefore, you are already stepping into the negative points, but that doesn't matter. I think the overall outcome is not only to win, I think winning is always the important part, but learning is also a key factor here. So next year you can you just read all the hints, and next year come more prepared, and you will be just rolling through this. Now, with this, I will conclude the overview. However, we have our partners who are running and providing us with the CTF. Now, this is a CTF Tech together with Cyberxer Technologies, and I would like to quickly invite on the stage Merki from CTF Tech to share her feelings. Welcome on the stage here.
Thank you so much. Thank you, Dr. B. I'm so happy to be here physically at this physical event, and together with Cyberxer Technologies, we are always happy to cooperate with you, with CERT-LV, to help to organize CyberShock and CTF. So I know also from my resources that competition is very tough. I tried to test some of these tasks myself, couldn't make it. So I would be positive, most probably the one who would be on the negative side with minus points right now. I think another point I wanted to make is that if I look at Latvians in general, your CTF players are known for very high skills of ethical hacking. We are just preparing for another big CTF called Cyber Battle of Nordic Baltics. It's for students. It's in the end of a month, physical CTF in Estonia, in Tartu. And there, in qualifiers, we had altogether 30 Latvian teams of 5. So a big competition for only one seat in the final. So you are doing good. Latvians are doing good, and I think that as a CEO of CTF Tech, what makes me particularly happy is that with competitions like CyberShock CTF, competitions like Cyber Battle of Estonia, Nordic Baltics, we are shaping the next generation of cybersecurity experts, which we have global lack of. So this is what is important.
Right.
Thank you.
Do you have any advice to the current players that are fighting through the CTF? Like take more hints or don't take hints, or sleep during night or don't sleep during night?
I think one thing is that I always encourage teams to do is to communicate with each other. Because normally what I have seen from my past experiences and CTF competitions is that if you don't communicate, if you don't work as a team, no matter how smart you are, cyber smart, you most probably don't win. So cooperate.
All right, thank you. And a round of applause to our partners. I'll take the microphone as well. Oh, thank you. The microphone goes to me, and this is to you from a small gratitude token from the CERT-LV. Thank you again. Thank you, everyone. And with this, we conclude the day, but this is not yet the end for the conference itself. The CyberChess conference today, unfortunately, ends, but that is not the end for the CyberShock. The technical track, CyberShock, for the CERT-LV carries on tomorrow. We will resume at 2 o'clock Riga time, and see you there. See you then. Bye-bye. Take care.